All right, you're recording right now. Ground lesson or time building ground lesson 2. Let me do it and present the slides. Do you guys see my screen?
Yes.
Okay,
Yep.
awesome. Great, great. So for today's class, we're going to focus on the weather and some traffic pattern operations for different airports, towered and non-towered airports. For the flight, any flight that you're going to take, even within vicinity of the airport, doing traffic pattern is always advisable and required by law, and also common sense as to us pilots to obtain weather briefing. It can come from many sources. As I said, you can get it with the full flight, Garmin Pilot or Garmin GPS. That will give you some sort of weather expectation. It can be METAR, it can be TAF. For most of the parts, for flight is kind of approved by the FAA, so you can go ahead and kind of have that as your backup. But as I mentioned yesterday, if you get into any situation, normal or abnormal, they will ask you to bring the proof of your weather briefing. You should show them something that proves that you already have done your pre-flight action, which includes obtaining weather briefing. For that matter, you can take screenshots, which for each flight, I don't think it's a kind of really convenient way, but you can go ahead, take the screenshots of the meter and TAF that you already obtained before the flight. And easiest way to to use the free service provided by the FAA and government, and which is uh, kind of weather briefer available to our pilots. It's free. You just have to go ahead, make a phone call, give them the information, and they will brief you about the weather. So any chart that you have to go look for it and put the pieces together, they already have it on the screen. So they would just go based on that. If we have time today, I will go ahead and make a phone call, and we'll have that as a sample for you guys once you're here. But the source of weather briefing can come from private sources, or half private, half governmentally funded, or
Um,
fully governmental funded.
One
Yes.
question: is it
Sure, go ahead.
possible online? Do they have
Yes.
an online page where you can check it?
Yes. I
Okay.
will show you shortly how to do it. But again, you either have to take screenshots or take
Okay.
photos with your phone or print that out.
Okay. Thank you.
I will show you how to do it shortly. Yeah, sure. And for us in US, the way we get the weather briefing, that free service, as I mentioned, is provided by the flight service station. Flight service station, it can have a frequency in some of the stations, but it's a phone number that you can call based on the region, based on the state that you're going to fly from. They will give you the information. Hopefully, we can make that phone call, and I will go ahead put that phone number shortly in the chat during the break. Well, once you call them, they will give you these information here. So this is the phone number here. I can give you, I can go and give you the exact like digits and stuff like that. And you can also sign up in the website. You would get an account with the number, subscription number. They're kind of something. I don't have the account. I'm gonna be honest with you. I always call. I tell them, okay, I don't have the account. I just want the standard weather briefing, and they're more than happy to do it for you. But if you want to take additional step, you can go ahead, create an account with them, and you can also obtain it online, log it for your flight, or you can make that phone call. So as I said, any phone call that you're going to make on this phone number will be recorded in case of anything, any hopefully not any accident, anything, even regular RAM check. You can go ahead, give them the time, and they will take care of the recording. So they will go and see that you've already done your part, and that wouldn't be a problem. And for US, we have different types of weather briefing. With a standard weather briefing, abbreviated, Outlook, and there's another one which is not included here. Is in-flight weather briefing. The reason it's not included here is because it's an optional step. A standard weather briefing, you just came up with the flight plan. You just came up with the idea of flying today, and you just want to see if the weather looks good. As of right now, I can see the sun. I can go look outside, see without some high clouds and stuff like that. but I'm not 100% sure. Okay, is how is my destination? Obviously, I can go ahead, take a step, check the charts. I will show you the website shortly, but I can go ahead do kind of a preliminary check for myself. Just go over the meter real quick for the departure point and destination point, run the tab and stuff like that. Then I can go ahead, call the weather briefer and ask them for a standard weather briefing, which is on the left corner here, a standard weather briefing. When you when you tell them that you need a standard weather briefing, that means you kinda have no idea about the conditions right now at departure point and destination point. So they will just go through every single chart and they will give you the information. The same exact charts that you're going to see on the website, I will show you. They're gonna have access to same exact information, same exact the database, and everything is the same. They just organize it in a way that matches this. First, if there is any problem, any icing condition, any turbulence, microburst, wind shear, anything, they will advise you. So any kind of adverse condition, anything, they will let you know. It can be Airmat Sierra, it can be Airmat Tango, Zulu, and stuff like that. And depending on what he or she is saying, seeing on the radar and on the charts, the weather briefing may advise you about the VFR flight is not recommended because of low visibility, icing, low clouds, and stuff like that. Keep in mind, he's going to give you a hint that VFR flight is not recommended, meaning it doesn't really look good. But again, I cannot tell you what to do. ATC cannot tell you what to do. Owner of the school can make the decision for you. You understand what I'm saying? So at the end, it will be your responsibility as a pilot in command of the airplane. Even if you're renting the airplane from somebody else, owner of the plane cannot make the decision for you because you're the PIC, you're flying the plane. So you would have to either, if you're, for example, you know the airplane cannot handle icing, obviously you cannot fly into known icing condition with the Cessnas. So you don't discontinue there. So you don't know, okay, have your mindset that okay, I cannot make this flight because of this. But let's go ahead and learn more. So it's gonna be an experience for myself. This will be a hint that that will say it exactly like that. VFR flight is not recommended at this time, meaning it's not looking really good. Just be careful with that. Again, it would be your final decision. But if someone else is giving you hints, that means something is really bad. So don't even take the chance. Of course, if I'm going to take a short flight within two airports, 5 nautical miles apart, yes, I may be able to do it with taking some risk within the safety margin, right? That can reduce the safety margin, but still I'm safe. But if I'm going to a long country, 250 miles apart, I can't really risk icing and turbulence and stuff like that. Synopsis would be a general idea about the conditions over that area. It's going to be kind of combination of forecast and current condition. And then it persists to current conditions, explains to you about how it is at the departure point, exactly whatever he sees, a combination of METAR, first part of TAF, which is again the METAR, and radar summary charts, any radar charts, observation, anything. And same goes for the destination as well. So current conditions for departure and destination point. And in route forecast, which is going to be here, mostly winds aloft, direction of the wind, freezing level, wind direction, temperature, altimeter setting if he has that information available. And he would just advise you, okay, you might get some clear air turbulence, there might be some icing, wind might shift, so might have to kind of adjust your flight level and anything that is related to the cruise phase of flight mainly. And destination forecast will be forecast of the destination at the time that you're going to be there. So when if your flight is going to take 2 hours, by the time you're getting there after 2 hours, it should look like close to your current condition because at this time it's forecast. By that time that you're arriving there after 2 hours, it should be the current condition. If you are going to land at a high elevated airport. The airport elevation is, let's say, 5,000 feet, and you're in the mountains, and you get some turbulence with super hot weather, high temperatures. So it's going to definitely decrease the performance of the airplane and increase the density altitude. So you're not going to really risk it. But if you're going to be safe going there in the colder weather, so might have to wait for the night or the afternoon for temperatures to drop, then you can go ahead make decision about the flight. And winds aloft, anything pertaining to winds aloft, temperature, the direction of wind, as I said, it will provide it to you. This section is really important. The last two, they're really, really important. Let's say I'm gonna be one of those pilots with experience at, I don't know, 1,500 hours. I said, okay, I've been doing it for 1,500 hours. I can just go ahead, check the weather, check check in everything that I need for departure and destination point. Then I'm gonna hop on the airplane and go. Halfway through, you're tuning into ATIS for destination point, and next thing you know, the runway is closed. You're low on fuel, and you have no other options. That's why we always need to check the NOTAMs. NOTAMs notices the airmen. You have different types of NOTAMs. NOTAM D, FDC, pointer NOTAMs, and military NOTAMs. Military NOTAMs wouldn't really be applicable to us. D NOTAMs, anything regarding the airport, something is wrong with the airport or runway closure, taxiway closures, something is out of service, PAPI lights are out of service. You cannot, for some reason, you cannot taxi northbound on this taxiway. You have to go southbound, or if the ATC, because of taxi closure, has put a new instruction for our pilots, meaning that once you're landing, you cannot taxi back for takeoff on the taxiway. So you would have to taxi back on the runway. So you have to be aware of that. That's part of NOTAM D. NOTAM FDC, anything related to navigational facilities. If ILS is out for that particular airport, is if the VUR is not working, if some of the GPS waypoints are not available at that time, if they're doing some maintenance on the localizer, if anything related to navigational facility for any of those airports has kind of is under the maintenance or has some problems, they will issue FDC NOTAM. And last but not least, pointer NOTAMs, they're just pointing at, they're highlighting the important area of many FDC NOTAMs. If something has been resolved or partially resolved or fixed, they will issue a pointer NOTAM for that. They're then saying, okay, if the ILS was out, now localizer is back on service, but the ride slope is not working, or something similar to that manner. So you would have to kind of adjust or terminate the flight accordingly. And known ATC delays, the last one, known ATC delays. If you're doing the flight plan based on the minimum barely legal requirements and you're going to get there, hopefully land with only 45 minutes of reserve, and you don't have any other options around yourself, so you would have to land at that time of arrival over there, but you're not checking the ATC delays. Maybe for some reason, again, because just a simple example, it's a busy airport, and you have jets coming in, those private jets, corporate jets, and plus GA airplanes, Cessnas, Vipers, and stuff like that. Because of one system is down, because of the localizer or ILS is down, so they will have to revector all the jets. Instead of shooting the approach at 10 miles, they will have to go 50 miles out, shooting the approach, coming back to the airport. So that would delay the whole process for everyone. And they might ask you, okay, stay over this area and put you in the box. If you're not instrument rated, they cannot give you a hold. They will tell you, okay, stay within 10 nautical miles to the west of the airport, for example. And we'll tell you when we're ready to accommodate your request. So you would have to circle there for 1 hour and an hour and a half. Then you're already low on fuel. So you have no other options. Can you go land? Technically, At that point, no, unless you declare emergency. The moment you declare emergency, telling them, okay, you're on emergency fuel or you're on low fuel, you would need to land right now. They would have to put all of those jets on a hold, accommodate your emergency first. Then, by the time you're landing, you're taxiing off the runway, you're clearing the taxiway. They will ask you to file a report. While you're filing a report, they will ask you what's the nature of emergency. You would have to state low fuel. And next question always is why you were not checking the ATC delays if you know you were on low fuel, and why you didn't stop halfway through to get fuel if you check those ATC delays. So everything is like a chain of events. If you kind of pay less attention to any of these parts, it will be like a chain. It will pull everything bad out. It will mess everything up. And we lost the light here. Give me 1 second. The sensor went off. All right, all right, all right. All right, sorry about that. Okay, so let's go ahead and continue with the second one. If you call the weather briefing and you tell them I need an abbreviated briefing, that means you already checked the weather somehow, or you already had a standard briefing. You just want to get an update about if there is any TFR, any NOTAMs, anything. Keep in mind, TFRs are part of the NOTAMs, and if there are different types of TFRs, they will include it after ATC delays. So the weather briefer is going to tell you no NOTAMs available. That means either he doesn't have them or there are no NOTAMs. So you still need to be careful because you're the PIC. And no known ATC delays. TFR, uh, active TFR within 2 nautical miles southwest of the airport, something like that. So he will give you some information about any TFR that may be over that area as well. And once you're getting abbreviated weather briefing, it means you already checked the weather. You have some rough idea about how weather is going to look like. Either you took the initiative, you checked the charts, or you already requested a standard weather briefing, but previous student was kind of late, so you would have to wait another 2 hours. But you just don't want to rely on that old standard briefing. So you don't want to go through the whole process. You just want to get a quick update about everything. When you're requesting abbreviated briefing, they have no idea what you want. So you have to mention and specify, okay, I need an update on NOTAMs or winds aloft or forecast condition for destination or anything, any ATC delays, any TFRs, anything. And they will provide you the information. Outlook weather briefing is kind of really wouldn't give you a lot of information because you should only request Outlook weather briefing when the departure time, your proposed departure time, is more than 6 hours ahead. So if I'm right now is 8:19 here, if I'm going to depart at 2:30 p.m., I can go ahead ask for Outlook weather briefing. That will give me about a rough idea. I had basically same thing, but these ones are not going to be as accurate because they're all forecast conditions at that point. And as you're getting closer to your departure time, you would have to go ahead, get a standard briefing, make sure you're legal, safe, and you can safely perform the flight. And any time during the weather briefing you see something doesn't match, go ahead, raise the voice, tell them, okay, can you verify this please, very nicely. They're human beings like me and yourself, and they can make mistakes. So just make sure you're kind of visualizing everything at the same time as well. If you see something doesn't match, go ahead, bring that up. They can go ahead, verify or fix it for you. Again, Outlook weather briefing. As you're getting closer to the departure time, go ahead and request a standard briefing. Call them again, get a standard weather briefing. TFRs, I already mentioned it. If you're flying and the weather briefer tells you there are no TFRs, you fly through TFR by mistake or something, it would be kind of shared responsibility, but more toward the weather briefer because he told you there are no, he didn't brief you about TFRs. But if something pops up, accident, something, the president had to come in specifically at this location without any schedule or anything, the ATC, the current ATC that you're at, those centers or approach controllers, that will kind of give you a hint. Hey, there might be a TFR here. So would you like me to go as revector you around? If you're accepting that, make sure you're not going too far off from the course. Of course, so you want to go ahead clear the TFR, but you're not going too far, of course, because again, fuel is the concern, and the moment you deviate from your original flight following or flight plan, in a sense, you will kind of messing up the whole calculation and stuff like that. So just be mindful of the fuel, regulation, safety, and your personal minimums. Are you guys familiar with the personal minimums
Yes.
here? Yes. Okay. So, a lot of people, I'm being honest with you, they know what the personal minimums are. They know how to set it. Even for student pilots, they have some limitations on their solo endorsement, but I've never seen a lot of people actually setting for themselves particular personal minimums. For me, the way it works, I kind of fall into that category, unfortunately. But if I see something that is kind of far, never been there, at least I try to either use the Google map, visualize the flight path, get familiar with the area, or take an experienced pilot with me, friend or someone who is obviously a pilot. Or if I don't have any other options, first one would be cancellation. Some people call this technique being scared. Some people call it being not a professional pilot, but I'd rather to not take the flight than getting lost, hit the mountain, control flight into terrain, or even get busted through one aerospace and come back with a phone number. So I would rather to be called scare boy than illegal or have to call the FAA. With that being said, so let's go to the next one. We don't focus on the weather charts. Weather charts are available through this website. I can probably go ahead show you right now. It's a great time now. I would have to change the screen. Give me 1 second. I will go ahead share the website. It's on AWC Aviation Weather Center. You can go ahead. If you can see my screen here, you just chart AWC.gov. It will pop up. Then you open it. You have options here: METAR, TAF, final reports, statements, and convective statements. On top, you have kind of the same thing. Advisories are just for statements and airmets. And forecast, you can get winds aloft, TAF, pro charts, everything like that. Observation will be mainly focused on the radar charts, METAR, and pilot reports and stuff like that. Just just for quick practice, it doesn't matter if you go to METARs or TAF, they will give you other option regardless. But I always like to go TAF. You scroll down. We don't go ahead with the airports that we're going to be flying out of. Nice and Corona. So the Miami, Venice, and Corona. Here, you have an option to include METAR. If you go to METAR on top list, it will give you an option to include TAF. So because we already have METAR at TAF, so we don't go ahead and include METAR as well. You didn't hit this. You can get a rough idea if you're going to fly over there. You can see everything. Also, sometimes it happens to me too. I'm not afraid of admitting it. I see something that I forgot. I just, for example, in this case, I don't know what BR means. It means missed. But if I forget, I can go ahead, hit decode. It will show me, it will decode everything for me so you can see all information, everything. For those of you, I believe, are more comfortable with QNH, you can go ahead, have that value over here as well. It will give you altimeter setting in inches and QNH as well. I will decode everything for you, the direction of the wind, everything. Let me ask you this real quick. Whatever we see here, the direction of the wind, is it magnetic or true?
True.
Absolutely. Yes. And the ceilings and or the levels of clouds that we see
Wrong
here
word.
are those AGL or MSL?
AGL.
Absolutely right. Thank you for that. Yes. You would have to consider this when you're doing your kind of, if right now we have clouds here, I'm going to find Van Nuys. It says the clear sky is because the ceiling or the protein level is more than 12,000 feet AGL, so METAR wouldn't show it. But let's say at this time, we don't have protein at 15,000 feet AGL, so the airport elevation is 804. We just to make it simple, we don't count it as 1,000, so it's going to be 16,000 feet MSL. Thanks for that. You can see a lot of stuff here. You can go ahead and find the meters, pilot reports, radar charts, satellite charts. They're really useful. If you want to go ahead, take a look at that as well. I will give you everything. Uh, just one thing that unfortunately is not available with this chart. It's not available for each individual area. So it would give you a big area like this. Let me go ahead propose you with another example. These echoes that you see here, these areas, are those IFR condition, or those are clouds, or those are visible moisture?
Precipitation.
Exactly, exactly. So it does not guarantee that outside of here might be VFR. These are the precipitation, visible moisture. It can be in any form, but if you're flying exactly right at the edge, there will be some clouds, IFR conditions. Thanks for that again. And let's go back to the original slides. Do we have any questions so far here before we move on to the next one? If not, we'll go ahead and continue. And let me go ahead, switch the screen again. And we have those slides. Yeah, awesome. So we're sharing the screen one more time here. Weather charts, as I said, they can come from private sources and governmentally funded sources like AWC is fully funded by the government and organized by the FAA, which is an agency within the government of the United States. And you can observe a lot of information. So let's go to the next one. Product charts, surface product charts. We'll go ahead back to the website. I will show you those as well. Product charts, they're kind of simple, but they're available for every scenario. They're available for surface at 12 hour, 24 hour. They're available for current condition and 12 hours from the time of the issuance. Uh, this is single panel. You can see the time and everything issued at this time, Tuesday, June 15, 2021. And it will depict the area of IFR condition, moderate to light turbulence, and mainly for us, the main concern it would be the air masses. This would be a stationary cold front and warm front, and you can see kind of the pressure levels as well. This is to us, to be honest, it looks a little uncomfortable, a little weird to us in US, but I think it's really more comfortable for you guys from Europe because you're used to see these things. But you can analyze the uh, surface for the current condition, see where the areas of high and low pressure, as we probably know by this time. High pressure has bad visibility, but calm weather, like generalizing everything. And low pressure has good visibility, but associated with bad weather, meaning it has good visibility, turbulence, and stuff like that. And seaweed clouds come with it. This is the surface analysis charts. You can go and observe that, see what are the conditions for that specific area. For example, if you're in California, so you can see at if it was a current chart, low pressure area is approaching here, and you have a cold front. Cold front is kind of turning into warm front. It might be stationary. So if you're flying mainly out of Van Nuys, which is kind of like roughly speaking, it's gonna be here. So might get some stationary front, some solid bad weather, or it can be good weather. It depends on the condition before and after it. Any questions here? If not, we'll go ahead and move on to the next one. And low level significant charts. Those are, as I said, for the current condition. Well, depending on the time of issuance. It at the time of issuance, Wednesday, June 16th, 2021. This is the 12 hour, and keep in mind these are the low level. Surface going to whenever you hit 40, give me one second. Okay, 400 millibars. Generally speaking, is surface to 24,000 feet MSL. But since we don't have standard temperature and conditions every day or every minute, it's constantly changing. Uh, okay, and any altitude that you hit 400 millibars, roughly in the standard day is gonna be 24,000 feet. But these charts are from surface to 400 millibars, and this is for 12 hours. This is for 24-hour surface all the way to. I would have to give this another shot because the presentation is not really cooperating here. Anyway, so you have those other conditions here. Actually, give me one second. I would have to reload that. Apologize for that. Let me go ahead. All right, awesome. Let's see if we can get it right here. Okay, awesome. And you have those. Okay, I would have to go ahead share my screen again. Perfect, perfect. So you guys are seeing my screen. Awesome, nice. Say that within this area, within this closed area, you would get some moderated greater turbulence. You did some marginal VFR in this area. You did some IFR here. You might encounter some freezing level within this region here. You did the top, you did the bottoms. These are MSL values, and open the top is unknown at this time based on the reports that they have. This is for 12 hour from surface to 400 millibars, typically 24,000 feet, and this is for 24 hours from the time of issuance. So they're kind of a combination of forecast kind of combined with the expected near future conditions. So they're mainly for forecast weather. Any questions here? At the end of these, I would always show you how you can obtain those on the same website as well. So let's go ahead and move on to the next one. Now, the previous charts were from surface to 24,000 feet or 400 millibars. Those are mid level, going from 21,000 feet to 45,000 feet. And you can see kind of the same concept. You get the wind region at what flight level, and you see the IFR, well, IFR condition with the icing and stuff like that. You can see some bad weather. Bottom in this case, I'm not sure if you can say it, the re assessment, the bottom is not recorded, but the tops are 13,000 feet, depending on the previous one. And you get some ultimate settings as well, depending on how you interpret this chart. You can get a lot of information out of it, but mainly for our concern, because we're not going to operate even at mid altitudes, we're just going to focus on the surface to 24,000 feet ones. If you don't have any questions, we'll go ahead and proceed to the next one. And those are the high level, same concept. You have like the same concept going from 40,000 feet to 65,000 feet, same concept. So you can see the rotation of stuff, bad weather, direction of the cats, clear air turbulences, and I don't know why is this happening. Okay. Same thing, same scenario, freezing level, and if you're going to fly, I would say at let's say 47,000 feet. If you're going transatlantic, so you can take advantage of this chart, kind of find your way going around the bad weather or adverse conditions. Any questions? If not, we'll go ahead and continue to the next one. AirMat. These are pertaining to us. Please pay attention here, and you're gonna probably Most of the time that you're going to get some sort of weather briefing, you will hear Airmet Sierra Tango Zulu. Airmet is an advisory in flight weather advisory that is hazardous to all aircraft, but mainly to light and kind of small airplanes or aircraft. It can be pertaining to helicopters, us and low Cessna 172, but hazardous to all aircraft, mainly for the small and light ones. And they're issued every 6 hours, and they have the issuance time on bottom of the description, or or it's already included. I would always show you that as well. And different types of airmets. They have Sierra, Tango, Zulu. Airmet Sierra for IFR condition and mountain obscuration. If the if you remember, we go back a little bit and that weather briefing. If the weather briefer tells you, okay, you might encounter around the airport, around Corona or Miami Airport, you get Airmet Sierra. So that means you have IFR condition around either. If you don't see it right now, it's approaching to that area, or if you see some clouds, so that's 100% IFR. That's IFR condition and mountain obscuration. You don't want to even take that chance. A lot of people, which is safe. I admire that a lot. If they're not 100% proficient in instrument flying, if they see Airman Sierra or IFR condition next to terrain, high terrain, hills, mountains, stuff like that, they will not even take the flight, which is admirable. I respect that, including myself. I'm instrument rated, but based on my experience, based on my personal minimums. Do I feel comfortable doing that and going to take the flight? Probably not. So if I see Airmat Sierra, I will have to either delay the flight or cancel the flight altogether. And you might even have Airmat Tando, which is Tando. If you, the way you can memorize that, Zulu is kind of cold for icing. Tando is like a dance for turbulence, and Sierra is for IFR condition. So Tando is for moderate turbulence and surface winds that are exceeding 30 knots or more. So moderate turbulence, it can be microburst, wind shear, anything in that nature, and associated with surface winds up to and even exceeding 30 knots. Last but not least, we have Ermatsuru, icing condition, and freezing levels or low freezing levels. You can encounter a freezing level at any altitudes. That's why you need to check the weather. Make sure you're not flying into known icing condition. The airplane is not approved for that, and even the airplane is approved, you should be aware of the ice, what it does to the airplane. It basically ruins everything. So I wouldn't take the chance at all. But since in our case, pertaining to us, the airplane is not approved to fly into known icing condition. If you see Ermatsulu, you should avoid the flight and cancel it altogether. I would like you to go ahead, take some notes here out of this slide based on your likings. Take a picture, take a screenshot. I will give a couple more minutes or seconds, if you will, and we'll go ahead and move on to the next one. And any questions, go ahead and ask me. And if you guys are ready, yeah, sure,
What?
go ahead.
Yeah. Sorry. Just what area do these cover? Does it vary, or is it like a certain size area that these airmets cover?
Size, the like size wise,
Yeah.
it can cover the whole state.
Oh, okay.
There can be IFR condition over the whole state, or moderate turbulence coming from it can be just the one line, so it's not really designated dimensions. It can be like shape of cloud or line coming from north to south. It depending on the conditions.
Okay.
Okay, awesome. So if no more questions, we'll go continue to the next one. Airmat, I would always show you the same exact thing on the website if we have time. So as you can see here, you see these ones, the airmats are with this color, and the other ones is just for the turbulence. If you again, if you have any of those apps on your phone, iPad, it's very straightforward. It tells you airmat Tango, this altitude to this altitude issued at this time. It's valid. It's going to be valid to this time. If there are any pilot reports associated with it, it will include it at the bottom, and it will give you altitude, time, and issuance time and date all together. On the website, you would have to hover the mouse over it. It would show you kind of the same thing because of turbulence or IFR condition, Hermit Sierra you have here, IFR condition. It will show you the same exact thing. It will show it to you like this. If you want to get more details, I will show you that as well. You would have to click on it. It will open up another page. It will give you all details, but everything is abbreviated. So you either have to know everything or have a legend to kind of interpret everything at the same time. But mainly, I know you guys are proficient by this time. You don't purchase probably most likely some for flight subscription or something, or even if you're checking this website, is going to be more than enough for you to understand and get a general concept of the conditions at that particular time and date. And let's go ahead, move on to segment. Segment are kind of more severe than airmet. Again, hazardous to all airplanes, aircraft, anything, helicopters, everything. And as I said, they're more severe than airmet, but they're associated with non-convecting conditions. So anything other than actual thunderstorm because of convection would be segment. Segment will include severe icing, but not associated with convective activity. If there is a convective thunderstorm, it will not be included with segment. So any severe icing that is not associated with convective activities and severe turbulence or clear air turbulence, CATs, as I mentioned, again not associated with convective activities, and dust storm or sandstorm that brings the visibility less than 3 statute miles over an area of 30,000 feet, square feet. So anytime that you get kind of any dust storm or sandstorm storms that are bringing the visibility less than VFR minimums, which is 3 statute miles, you will have segments so issued for that particular uh, phenomena. And volcanic ash, if the volcanoes are erupting, you will have segment as well. Over Michigan and stuff like that, they're always having some sort of kind of low visibility because of volcanic ash, and they always have segments available. I might have to ask you this, which is kind of advanced. I just want to make sure that we're on the same page. What are the hazards associated with volcanic eruption? What can you expect, and why you should not fly through that? Any ideas here?
Dust and particles that could harm the engine. So you can have
Absolutely.
a burnout. Should avoid these conditions.
Absolutely, that's 100% correct. Appreciate that. Thank you. Yes, it will damage the engine, airframe, low visibility. The engines will seize. It will add weight, and you're basically in a bad situation. Thank you for that once again. And if you guys want to take pictures, or screenshots, or take notes, I will give it a couple more seconds, and we'll go ahead proceed to the next slide. So if you guys are all set, I will go ahead and move on to the next slide. Again, same exact concept with the segments. You're gonna hover the mouse over that area. It will show you the identification for this station that was issued from, mainly an airport, or it can be fly service station as well, FSS. But mainly they're issued out of one airport, those big international airports. I will show you the name of the station, identifier, and it will give you the description here. I will show you again, same thing. Valid from the validation time, date, and everything in that manner. And this is the simplest version here, and the other one is just a full format. You would have to go ahead and interpret that as well. And keep in mind these ones for not mainly for airmet, but for segments and convective segments, they're kind of referencing those off of VOR or navigational facilities. So they will tell you uh, between radial of 090 to radial 120 out of, I don't know, this VOR, you should expect low visibility, and within radial of 130 to 250, From this altitude to this altitude, you will have freezing level with embedded thunderstorm and stuff like that. So just if you see something with the radials, uh, it's basically referring to an aviation facility. And if again, if you need more information, you can go click on it. It will open one complete page. It has everything. On the fourth flight, we don't get a lot of statements here, to be honest, in California or Florida. If you want to check somewhere else, you would have to really, in our case, really look for it to find the segment going over that chart. But if you do it, do it with the fourth flight, and then it will show you the simple version, like in plain English. It's not to give you like 2 pages of description, but like simple abbreviation in plain English. And if you need again any pilot reports, anything, if somebody flew through seed method area and encountered embedded thunderstorm, they will issue a PIRAP, and the PIRAP, since it's associated with SIDMET, will be included in the SIDMET description as well. Let's go ahead and move on to the next one. Last but not least, we get to the beast, convective SIDMET. Convective SIDMET is hazardous to all airplanes, and it's bad weather with convective activities. Up and down motion, severe clouds, bad and nasty weather. They're issued every 55 minutes. Each issuance is valid for 2 hours. It's a little confusing. So at, let's say right now is 8:47, at 8:55, or in your time, I believe it's going to be 5:45, 5:55, excuse me, they will issue new convective segment. And again, the previous one is still valid for 2 hours. This one is going to be mainly considered for the next 55 minutes, and it's still going to be partially valid the next 2 hours. The reason we have that, you might be asking yourself, so if you're issuing it every 55 minutes, why we have that? It's still going on for another 2 hours. So the reason is you can put those pieces together and get a big idea. So if something is changing, going toward the bad side or the good side, by putting everything together, checking it from couple of hours ago, if you're seeing the conditions are improving, so you can expect some improvement in future as well. If you see something is going down, the weather is getting worse and worse and worse, so possibly it's not going to get any better any soon. Uh, with that being said, so let's go ahead, continue with the items that convective statements are issued for. Embedded thunderstorm, you might get some IFR condition, but the thunderstorm might be embedded. It's within the clouds. No radar can detect it. You just see some IFR condition. You're flying 737, so that wouldn't be a big problem. But halfway through, you encounter a thunderstorm. That's called embedded thunderstorm. A line of thunderstorm, a squall line with a line of cold uh, fronts, is issued for if you see convective segment over long area or elongated area, you should expect a line of thunderstorms. And tornadoes is issued for tornadoes as well. Surface winds that are greater than 50 knots. Any That's just crazy. Like 50 knots is too much. Anytime the surface winds are exceeding 50 knots or more, going up to 110, I believe it matches that. It will issue a convective segment. And hail greater than 3/4 inch in diameter. Anytime you get hail more than 3/4 inch over area, again, it can be same thing. It can be specifically over one city, it can be over one state. It can be half of U.S. It can be an elongated portion of going from north to south, going from if I can give you some references here, from Washington to Nevada, coming to California. It can have any shape, so they don't consider that area. And if there different points that the kind of convective activity is going on, they will issue airmat segment or convective segment for each point. So you're gonna see airmat here, another airmat over there, another airmat on the east coast. Same thing. There might be combination of all of those as well. And if you get thunderstorms with the heavy precipitation, that are affecting 40% of area of 3 square miles. If you get precipitation, that's gonna affect 40% or more of 3,000 square miles. You will get convective segment as well. And if you're wondering how it will look like, I can promise you same thing. You're gonna have the same thing, the different color coding with different information, of course, for convective segment. And you can go ahead find those on the website. We'll go ahead cover that as well. Again, I'm repeating myself, but let's go ahead and make sure we're on the same page. Convective segment. You're checking the convective segment over this center is issued by the Center or Control Facility, FSS, or the airport. In this case, I believe it's an airport, but it can be over center, over approach controller, or those center controllers as well. And beginning time, ending time, uh, the tops, it can exceed up to or more than 45,000 feet MSL. That's kind of more abbreviated version, and you don't see everything here. Mainly, we should know this, but this wouldn't be our concern because if anytime you get even airmet, we can fly. I'm be honest with you, we're not through it, we're not ready for it, and the airplanes and our limitation as pilots is not really capable of handling even airmet. Sometimes some light airmets, if you're going to do some IFR flights, as I said, uh, IFR flight still comes with other hazards, comes with a lot of issues that you need to be either 100% prepared or not going at all. Any questions so far here about this? I will go it back here one more second if you want to take some notes. If you would like to take a screenshot or something, go ahead. This is the time. And if you guys are done, we'll go ahead and continue to the next one. All everything that you see here within this slides, everything will be available in LMS time building sector. You can go ahead and study it or double check it or refresh your memory as well. So don't worry about it. And we got some icing forecast. It can be for current condition or icing forecast as a forecast for you guys to take the flight. They're coming in different charts. Let me go ahead go back here. And you can have these charts, you can have these, you can have these, you can have these. Uh there are minor differences kind of between each. These charts will show you the general area of icing condition. Here, you will have to select the sector. I will give you the exact details, including any pilot reports. Here is going to tell you how severe it is. Here, based on the color coding, you can go and estimate the freezing level. It starts and ends at what uh, altitude. Unfortunately, due to smart cut here, that legend, the strip is not included. But based on the color coding, you can go and estimate the height or what altitude you might encounter the freezing level. Basically, if you have freezing level, again, we can't fly. If you just want to check it, you just want to double check it, make sure there are no freezing level to take the flight. By all means, go ahead. Use these charts. Again, your best source is going to be Weather Briefer. Those charts are available in our website. Also, on the website that I showed you, I will go ahead and cover that as well. Any questions here? If not, we'll go ahead continue the next one. Again, you say get the same charts. I'll probably repeating myself. It will show you the general area of turbulence. You would have to select the sector here. Then based on the sector, it will tell you including pilot reports. For these ones, let me go ahead and mention that here. If you're seeing a pilot report, a PIREP, which is called pilot report, from Boeing 737 at 17,000 feet, or even Boeing 737 taking off from Ontario Airport, encountered light turbulence at 2,500 feet MSL. That's a 737. So it doesn't mean it's going to be light for you in a Cessna 172. So it's going to be kind of severe to greater turbulence for you. So the airplane cannot even handle that. Always when you're checking the pyreps for anything, icing, freezing levels, for turbulence, for any reports, keep in mind to check the type of the airplane. 737 might not even feel light turbulence, which is severe for Cessna 172. So just have that in mind. Again, here you would have to select the sector. It will include information, what altitude it starts, where it ends, any pilot reports associated with it. Here is going to tell you how severe it is based on the color coding. Any questions here? Anything you would like me to cover? No? We can go ahead and move on to the next slide before we take a quick break. And winds aloft. It would be at this time up to you guys. We can go ahead, take a 5-10 minute break, or we can finish this, then go ahead and do it. To me personally, I would like to finish this and go ahead, take a break. If you guys agree, we can go ahead and continue. Sounds good?
Yeah, go ahead.
Awesome. Awesome. Perfect. Yeah, so as I probably you guys heard me saying winds aloft, winds and temperature aloft, it will be useful for your cruising altitude as well as the weather briefer will see the same thing. So that's how she or he will brief you about those conditions at your cruising altitude. The winds aloft are issued basically from the beginning. So let's go ahead and start from the beginning. It gives you the information about wind direction, speed and temperature for each cruising level or flight level. Flight level wouldn't be really applicable because we're staying mainly till here below 18,000 feet, but we don't call it cruising level, including the flight levels. And the winds and temperature, love temperature or charts, sorry, the reports are forecasts. They're not observation, they're forecasts. They're issued twice a day at 0000 Zulu and at 1200 Zulu. And winds are being shown here based on the true heading. Keep that in mind. That are shown based on the true heading. First, because the sensors and the stations are set based on the true heading. Second, you don't use this for your pre-flight weather, pre-flight planning to plan the cross country or plan the flight. So you would have to have first true heading, then consider wind correction angle, then add or subtract deviation and variation from it. Then you will have the final magnetic heading or compass heading. I gave you two reasons why they're issued based on the true north. And anytime that you see, for example, over this station at 3,000 feet MSL is empty, or here at 6,000 feet is empty, or combination of both because it's in the middle. The reason is because the this station is located more than 1,500 feet AGN. So that's why the height between 3,000 feet MSL and the airport elevation is less than 1,500 feet. So because the airport is higher, right? So it would give you the less distance or vertical height between that station from the field elevation up to 3,000 feet. Because of that, because this distance is less than 1,500 feet, it will not provide you any type of information. So it has to be more than 1,500 feet AGL to be able to give you some sort of wind and temperature indication. And it depicts freezing level. It has some notes here as well. Also, also you should remember that above 24,000 feet MSL, temperatures are always negative. So if you pay attention here, 24,000 feet, negative 20, negative 20, negative 20. 30,000 feet is already eliminated. They deleted the negative or minus sign because based on this note and based on what we're kind of talking about right now, above 24,000 feet, everything is negative, 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 negative. To make it easier, they kind of eliminated that minus sign as well. Let's throw it run quick samples here to get to know these charts. Do you guys have these charts in Europe?
Yeah, we do.
Okay, awesome, awesome then. So we don't really have to go deep in this thing. So as you probably know here, 9900 plus 29 means the wind is calm, less than 5 knots, and is variable, and its speed is less than 5 knots. Temperature is plus 29. There's another sample here. Wind is blowing at wind is blowing from 220 at 26 knots, and temperature is plus 11 degrees Celsius. There is a tricky part, as you guys are probably aware of it at this point. These ones here, 720, these numbers which we don't have the direction of 720. So anytime wind speed exceeds 99 knots, in this case, in this example, is going to be 102. They will do it this way. So you would have to subtract 50 from the first two digit. So if you subtract 50 from 72, it's going to come at 22. So wind is coming at 220 at 102 knots. And is here probably, as you can see here, is above 24,000 feet. So they eliminated the minus sign. So negative 44 degrees Celsius. Any questions here? Anything so far regarding winds aloft? If not, so let's go ahead. Right now, probably for you guys, it's 6 p.m. 6:01. For me, it's 9:01. Let's go ahead, take a 9-10 minute break. We'll come back at 6:10. Sounds good?
Yeah, sounds good.
Okay,
Sounds good.
perfect. Thank you. Good morning, man. How are you? Same exact question. All right. If you guys back, so let's try to continue with the next one. Uh, we're going to talk about meter. Meter is kind of expected weather conditions within 5 statute miles from the primary airport, from the station, from the center of the runway. It's specifically geared for that specific airport. It will it's kind of an observation. It's not a forecast. It's just observation for that airport, and it is valid between 45 to 55 minutes from the time of issuance. So basically, they issue it at the beginning of each hour, and is mostly valid for the next 55 minutes. From 55 to that 60 mark, that 5 minute, they will get ready. They generate the next one, and they issue a new meter. When you're checking the meter, keep in mind the winds are based on true, and any ceiling, anything that you see, any layer of clouds, they're based on the AGL. There are many sources that you can go ahead check the meters. You can again use the ForeFlight, the Garmin GPS, and stuff like that. You can go to AWC as it's been detect- detected here. So let's go ahead, go back. We're gonna go too far. Go back. I'm getting too many alarms here. All right, and this is a sample, and you can also see the meters in our website. There's instruction here. You can also click on the link. It will take you directly to the meter. This is a sample. You guys are probably familiar with this. All the airports in US, they start with K. The next three digits or the letters are the identifiers. Where some airports they have combination of digits and letters, and you'll see that around Southern California a lot, Big Bear, and a bunch of other airports. So basically says meter, station, time of issuance. And it was auto. It wasn't kind of in manual observation. It wasn't issued by any airport staff or anyone working in the tower or stuff like that. It's auto based on the system, sensors, and computers. Wind is from 140 at 21 gusts 26 knots. Visibility 3/4 statute miles, and heavy, I believe, thunderstorm with shower and rain. BR means mist. Broken at 800 feet AGL. Overcast 1200 feet AGL plus CV clouds. Temperature dew point a altimeter setting 2970. And remark, this thing you can probably go ahead to look it up in the legend. If I'm not mistaken, pressures are falling rapidly. So there is a rapid changes or decrease in the pressures that are being kind of put in the remark section. Again, you can go ahead see those information on AWC, our website, and any type of approved source that you may have. Any questions about the meters? I believe you're all familiar with those. So let's roll it, proceed to TAF. TAF stands for Terminal Area Forecast. It's a forecast. If you select TAF, it will give you the meter plus TAF. Not every airport has TAF, only for selected areas and stations. So as I said, the TAF will include meter as well, and TAF by itself is a forecast. So meter is an observation, TAF is a forecast, and it is valid. It's issued for the whole throughout 24 hours, and some stations the tabs are even valid as long as 30 hours, and it is issued 6 hours in segments, so for 4 times a day, but depending on the conditions and everything else, depending on the conditions of the airport, depending on the facility, depending on the requirement, traffic, and everything like that, they might be issuing one for 8 hours, the other one is for 6 hours, or any some or sometimes if there is any changes, rapid changes that are expected to happen in short amount of time, so they're gonna adjust the validation time as well. Keep in mind, TAF is only valid from again same thing, same concept within 5 nautical miles or 5 statute miles from the center of the complex runway, from the center of the airport between two runways, complex runways. It's sending outward only 5 statute miles. It will give you the validation time, wind, visibility, weather, and ceiling. I believe the I can draw it probably just a quick uh reference. We can do it. Trying to switch the screen right now. Recruit. I'm gonna show you one sample of TAF that we have already covered, but let's go ahead check it out again together. Since we still have time here, I would always spend a little more time here on on the slides as well. Uh, TAF, you go to forecast. TAF, you can also go to home, then find it the other way too. But since we're already here, we went to forecast, TAFs. You can also find for each station, but since we don't want any of these, we want the specific ones. Again, keep in mind, as I said, not every airport has TAF. So we can check Van Nuys, Burbank, and B and Ontario. And it has the meter with TAF expected from the date, time in Zulu, 22, 2100 Zulu. In this case, this is for Manas, wind 140 at 7, visibility greater than 60 statute miles, and broken at 15,000 feet AGL. That's a true example, same thing, same concept as a meter, just the main important thing. Meters are observation, tabs are forecast. Let's go ahead, go back to the original slide here real quick so we can continue with those. We go to the tab, if I can select it here, yes. Okay, awesome. So we're all familiar with this. Pilot reports is are again observation observed by the pilot, reports that are being made by the pilots to the controller to help other pilots out. Um, in concept as meter, GAF, again, same thing. It will show you the description. You have urgent and regular or routine pilot report. If there's an urgent, for example, the pilot hit some bad weather and it's really severe, he wants to let every other pilot know that they're flying probably same make tomorrow. It's really severe. That will issue an urgent pilot report. Otherwise, it's routine. Um, you can see basically everything over what it was reported to what the station. Again, probably off, same station, time, flight level. Yeah, it's basically everything. To be able to do that, there is a form. I can probably always show it to you again, but I'm sure you guys are familiar. You can always use the form as you do it more often. I've done it only once, but as you do it more often, you become more familiar with it, more proficient, and more effective. So you can do it faster, run it quicker without using any form. And again, it's been kind of dissected here. You can see everything: time, altitude. Again, this is the main important thing: aircraft type. If again, same concept, a 737 reporting a light turbulence, it's not going to be light for you in a Cessna 172, Cessna 152, or Cessna 182. Pay attention to all of these. This is just a rough idea about what that pilot saw at that particular moment. Does it mean it's going to be applicable to you? Possibly no. It's not going to be 100%. It's not going to be guaranteed condition. That just the overview, what the other pilot saw. So if I'm going to the airport here, I see everything is fine. And the weather briefer told me there might be some light turbulence, but to be honest, I don't see anything. Our charts are kind of fine. Everything is fine. But if I see this report for that specific airport, so I can expect some turbulence. Either I have to deviate or delay or go through it if I can safely. I guess we're all familiar with this. You can get a lot of information from these charts. Very useful. Really, really good for us from pilot to another pilot. And high altitude operation. So let's go pay attention to this. For the sake of time building, some of you guys might be planning to go to Big Bear, some nice areas that we have around here. Very nice. In California and Florida, both. Mainly for Florida, it will be high temperature. For California, it would be high altitude and high temperature combination of both. But if you're going to operate in a high altitude airport or doing some high altitude operations, just always follow the checklist. If you're arriving here, my advice to you, uh, if you're arriving at night, you're going to fly tomorrow. At night, if you're not tired, just download the POH from the website, our website, or if you can make a hard copy, that would be great. Just make some copies, go through standard procedure, limitation, general, emergency procedure, stuff like that. Cover everything because checklist can cover so much. After that, it would be your knowledge. Checklist has to be quick, brief, simple, and abbreviated. It cannot give you the line by line what to expect for this make and model during emergency situation. So just open up the checklist, go through it, make sure you know everything about that airplane is required by law. You don't be checked out on that airplane, and the flight instructor expects you to know everything. Also, for the sake of ram check, and last but not least, common sense. In this case, for this airplane, which is common standard procedure for many airplanes, if we're going to take off from high elevated field, which is in this case in California, it's going to be Big Bear, but if airport elevation is at 3,000 feet or higher, you should lean the mixture for best RPM, for the maximum RPM. So you're going to lean the mixture out, you get the RPM increases, then it goes back down slightly. The moment you see that, you have to enrich it again to obtain the max RPM. Just go ahead, follow the checklist, go through POH, and make sure you're familiar with these procedures as well. This is the exact description from the POH. You can see it here, above 3,000 in the mixture for best RPM and stuff like that, adjusted for rate of climb. And as you're climbing, you should also lean it out more to some certain point. Make sure you're familiar with it. We're gonna go ahead and continue to the next one. We If you're going to take off, for example, for the sake of taking off from that high elevated airport, just try to use as least amount of runway as you need, and you should just perform always a short field takeoff, because in case of anything, you can also even stay in ground if it helps you to gain more speed. Then you climb out, or if you get into emergency, you still have plenty of runway to safely stop the airplane. Just add RPM to 2000, depending on the checklist. Just add up the RPM, make sure engine gauges are green, then release the brakes and proceed to takeoff. Check the spark plugs, check the magnetos, go through every single checklist, go above and beyond. Not too much, not too little, just enough to be safe and consider it to be a safe pilot. High temperature operations will be really applicable to us. Again, kind of the same thing. The concern is they have kind of because of high density altitude for those areas, either because of high temperature or high pressure or high altitude, you will have high density altitude, which is gonna which the airplane is gonna perform the least. It's gonna degrade the performance. At the same time, you will lose a lot of power. So just again, same procedure. Anything you would have to lean the mixture for best RPM. In this case, as you probably see it here in the checklist and the POH, you should increase to 1800 or 2000 RPM. Then for a minute or two, do the pre-takeoff or run-up check, then bring it back down, go through the checklist. So that's pretty straightforward. Again, I cannot cover everything. We can cover so much within this time. It would be depending on yourself as pilots to go ahead and take care of that. And we already covered that. And the performance charts, they're really important. We should know about those. So, for example, for Cessna, if you're going to
So
fly,
I've just got a quick one. Sorry.
sure, go ahead.
For like high density altitude or high temperature, for complex aircraft, do you have to do anything with the prop? Would that affect it in any way, or can you just leave that full forwards?
For the sake of high or the complex airplanes, it should be always full forward. Otherwise, it's stated by the checklist, but prop is the position of the prop is not going to really interfere with the performance of the engine. It's going to interfere with a lot of other stuff, but it's not going to interfere with the performance of the engine. So the concern for those high density altitudes to get the most out of the engine, then based on whatever we get, we can set up the prop. But since the margin between the performance loss, and the performance gain is not really great. Unfortunately, we just leave the prop full forward. So if you're going to
Okay.
fly the complex, prop is always full forward during takeoff and landing.
Okay. Perfect. Thank you.
Perfect. My pleasure. And just since you already mentioned that, I'm going to just quickly mention that as well. If by any chance you're going to fly a high performance airplane, those multi engines, if they are high performance, anything, any time at your flying career, you get to fly high performance. Some airports with the low elevation, if the airport elevation is 10, the Florida airport is 10 feet, 10 MSL. So you're basically at sea level. Some days, if it's super cold, you can't even go full power because the RPM is going to exceed the red line, manifold pressure is going to exceed the red line. So in those cases, as you mentioned, you would have to pay attention to the prop setting and the manifold pressure. Anything other than that, unless it's stated otherwise by the checklist, prop is always full forward. So let's go ahead and continue with this. For the Cessnas, they would give you only the short field. Anything else, you would have to go ahead adjust it based on the type of the landing or takeoff that you're going to perform and execute. But in this case, for the sample of this conversation and presentation, we have short field takeoff configuration at max takeoff weight 2450. Uh, Keep in mind during previous pages in the POH, they might give you a ramp weight, which is 8 to 10 pounds higher than this because of the fuel that you're gonna burn to taxi and do the run up. Keep in mind, you're always checking this, make sure you're all set. So max takeoff weight is 2450, and let's say you're at Florida, you're at sea level basically. Keep in mind this is based on the pressure altitude, but since we don't have the pressure altitude right now, so we're just gonna assume that's at sea level. Do we know how to calculate pressure altitude? I believe we do. 29902 minus current altimeter setting, multiply the number by 1000, and add that value to the airport elevation. And let's say we went through all that process with our sea level. Today, right now, is probably a little early, so around 20 degrees Celsius. You should expect 980 feet ground roll, and to be at 50 feet to clear the obstacle, you're going to be at 1,745 feet. So you need to have 1745 to clear the 50-foot obstacle, and technically to accelerate to your rotational speed, you would need 980 feet. Same goes for the landing. Um, let's see. Okay, in this case, maximum rate of climb again. The weight is 2450. So let's go back to something I should mention here. Based on this configuration here for the short field takeoff, you should have 10 degrees of flaps and accelerate or advance the RPM or the throttle, which is the same thing. In this case, you should advance the throttle, then check the gauges. Everything looks good. Then release the brakes. So this is the procedure here, and these numbers are based on the paved level dry runway, basically perfect condition. Anything other than that on the bottom, which is not included here, you would have to either take away or add 15% if anything changes here. It will give you some instruction. I'm sure we're familiar with that. The liftoff speed, the rotation speed is 51, and your VH would be 57. So let's go ahead, go back to the other chart, maximum rate of climb. Same concept. If you're going to climb out of sea level, your VY, which is indicated. If you're going to fly Pipers, that might give you true airspeed. This is indicated 79 knots. And at, let's say, 20 degrees, it's going to be 705 feet per minute. If you guys are unsure about any area, go ahead to stop me. But I'm sure you guys are professional pilots with a private pilot. You went through whole ATP course and stuff like that, so you're pretty familiar with these. But again, if you're feeling uncertain about some areas, go ahead and stop me. I will go ahead cover more on those areas. And we got operations over high terrain. Florida, not really, but you should again know everything. And in California, you don't be check that on those. You don't be check that on those. Just be real careful. High elevation, you might see it as something simple. You're just flying in the valley, you get the best view. It's much more complicated than this. You might encounter some IFR condition. You might get some lenticular clouds. You might get some mountain waves. There's a lot of stuff going on. But let's go ahead, cover that. Anytime that you're going to fly uh, within close proximity to mountains and high height terrain, going to Big Bear, going somewhere up north, you're flying around the or along the mountain ridge. Pay attention. You need the best condition. You need to pick the best day, the most clear day to fly. So make sure you have complete VFR day with possibly no ceilings at all. So everything looks like a hot summer day, but in with a really good performance and low density altitude. So basically the best day. And so you're gonna have to go through all emergency situations, know the route, know the area, use the Google map, use all the features and systems that are available to you. Just visualize your flight path. If you're going to fly close to mountains, you might get some turbulence. If there is wind, if there is any wind within that cruising altitude, it's going to hit the mountains, it's going to go over the ridge, and you will get some turbulence for sure, right? Make sure you're not flying too close to mountains. The mountain wave will suck you back down toward the terrain. If you go too far, you might encounter something else. If you operate too close, you're gonna hit the mountains. So just be familiar with the route. If the wind speed, or I'm sorry, if the wind speeds are at between 15 to 25 knots, you're gonna get some mountain waves. I believe we're gonna go ahead and cover that as well. Be mindful of that. If you wanted to go ahead, take a picture of it, take a screenshot of this, take some notes, by all means, go ahead. And be mindful of the turbulence. This is one of the main concerns here. Let's say you're one person and you probably have full tank and you're still probably 400 feet below the max gross weight, right? Or the max takeoff weight. And the maneuvering speed for max takeoff weight is around 97. And as I said, you're already 400 feet, 400 pounds below it. You're also burning fuel and you're light, basically everything in light condition. You're flying down at 110 knots. You're cruising at 110 knots, and you get that turbulence. So you're basically flying over the maneuvering speed. So you have to pick an area within enough proximity to the terrain to follow the flight plan and beginning of everything. If you can avoid it, just avoid it. Pick another route. Have some emergency landing areas available to yourself all the time. So you don't flying above maneuvering speed. You get some turbulence. You're fast, light. So obviously, and hopefully never, you may encounter some structural damage. So this is another concern. Uh, Southern California, these are the precautions. They're not kind of any scare technique. I'm just giving you some precautions and tips. You should know it as pilots, but it doesn't matter if I tell you or you get to that point to gain enough experience here. But since you guys are going to be here for a short amount of time, so I'm just relaying these information to you. You're more than welcome to take it or just leave it there. During morning, because of the mountains, we get that mist coming in from the shore over the land is gonna stay. You can get some low visibility. It still is going to be VFR by the minimums 3 statute miles, but it's going to be like 10 statute mile visibility. Last time, I flew with another pilot at 10 statute mile visibility. It was fine, but it wasn't really something that I would maybe try doing solo or by myself. So even 10 statute miles and during that condition wasn't really helping me a lot. So technically, you still VFR by the law, but just have lower visibility. Be mindful of that, and you're operating close to terrain, to mountains, to hills. So if you make one wrong turn and you're paying attention to the GPS, you're writing down the frequency, it's going to be disaster. And Icing will be another concern, low visibility, and everything that I've already explained. In California, Florida, basically a lot of other places, but for the sake of our presentation, we're focusing on California and Florida. Because of kind of higher temperatures, you will have lower performance and higher density altitude. So even if you're kind of distracted, now you see the mountain. It's coming toward you. Or you're going to flying directly to the mountain. If you want to climb, you should have enough distance to be able to climb high enough to clear the mountain. Just be mindful of that as well. And if no questions, we'll go ahead continue to the next slide. But let me take a sip of water. And as I said, we have mountain waves. Really important to know the indication. Obviously, you can't see the wind. It's been shown here, but in this real life image, you can't see them. So the only indication will be these type of clouds, lenticular clouds. They're being kind of formed at the highest point after the mountain ridge here, right? So this is the first indication that you have some mountain mountain waves. If you're flying here, you can get some turbulence, of course, right? And if you're flying lower here, the the rotors or the rotators will kind of push you down toward the mountain and toward the lower altitude, which is not safe if you're flying over the mountains. As I said, any time that you're checking the wind, you are kind of seeing the wind that is doing perpendicular to the mountain ridge at 15 to 25 knots. You should expect that, and it's going to happen. The first indication is going to be this type of clouds. Any questions here? Anything? If not, we'll go ahead and continue. Emergency situations. Will take us back to the first thing I said yesterday. Personal minimums, being familiar with the airplane, and the checklist. I cannot emphasize the importance of checklists enough. Do I know everything? No. Am I trying to learn more and more? Yes, absolutely. Do I know the important parts? Yes. Can I repeat it right now, line by line? No, but I know the general concept. So you don't have to repeat you don't have to memorize it line by line. So you have to have that deep understanding of why and how. During emergency, uh, you should, based on the route that you're going to take, likely in California, as far as I can tell you guys, you have a lot of freeways, you have a lot of small airports, so you can kind of be towards the safer side of that safety margin. But again, it doesn't matter. You should pick the best landing area, be familiar with the performance of the airplane, emergency checklist, and your ability as a pilot. I know it comes with the experience. I don't have a lot of experience. I never said that I have a lot of experience, but I'm trying. I'm trying to be better and better. You guys should do the same thing. Go through checklist. We can cover so much here. General concept is the same, A, B, C, D. We're gonna go ahead and cover that shortly. But how the airplane is gonna perform depends on what it says in the POH. With that being said, let's do a quick kind of recap about emergency. When you get into emergency, you have to first pick the best pitch for the best airspeed, ABC. Pick the best landing area. It can be alley, it can be a freeway, it can be a field, it can be a farm, or first thing first, if you have an airport nearby that you can safely make it, go straight to the airport, no doubt. Then run the checklist if you have enough time. Or if I'm climbing, just barely taking off, climbing at 500 feet AGL. If I'm losing the engine, I'm not gonna reach out for the checklist. So because I know the general concept, I'm gonna just run a memorized checklist, whatever I know, whatever I can, whatever I have time. Then I'm going to try to, based on the decision that I've made, based on the wind and a lot of other stuff, to navigate and land the airplane in a safe manner. We don't go ahead cover more about that, but let's go ahead move into this section. This is very important. If you get ram checked, you will be asked, and you're expected to know this. Since you guys are mainly dealing with kind of ATPL courses and stuff like that, do you guys have any familiarity with minimum equipment list and that kind of stuff? I know for those Airbuses you have POH. We don't have POH. It's called AFM because the airplane weighs, for the Cessnas, it weighs less than 6,000 pounds. So we have AFM, airplane flying manual. How familiar are we with these minimum equipment and stuff like that?
I'm not very.
Oh, okay, okay, sounds perfect. Okay, minimum equipment list: 14 CFR 91205. Let's say I'm doing my pre-flight. I'm checking the airplane. I see one of the equipments is faulty, or one of the equipments is not working. I tend to see that during my pre-flight inspection. Some to make it general, then we go deeper and deeper. Like like your car, some equipments are additional, some equipments are for the sake of just comfort, and some equipments are required to work. If you tell me, okay, the airspeed indicator is not working, I can't tell you if it's okay to fly or not. Technically, common sense, no, because something is not working. So it might be even chain of events starting from one equipment going to kind of affect everything else, or it might be just one faulty equipment. How can we detect that? There are many ways. But for our airplanes, since we don't have POH and we don't have minimum equipment list, so keep that in mind. We for Cessnas, for light airplanes, we don't have minimum equipment list. Bigger airplanes, they have proper POH. Airbus 320, they have minimum equipment list. It's the list of equipments the airplane cannot legally be flown without those in operation. But again, for us, the airplane weighs less than 6,000 pounds. We don't have POH. We don't have minimum equipment list. We have AFM, and we have kinds of operating equipment list. And because we don't have that list, FAA came up with the list of minimum equipments to be on board of the airplane working to be able to legally fly the airplane. Therefore, again, we call it that least minimum equipment list, but it's not same as the actual minimum equipment list. So let's go ahead and continue. And just before we do that, as it's been brought up here in this section here, if you can see here, I'm just going to quickly explain this. We go to the main important areas. If you're going to fly an airplane, which is for hire, it means either you're renting the airplane from the school, money is involved, or you have your own airplane. Technically, you can do it, but just for the sake of conversation, you're going to charge someone to take him or her from point A to point B, or you're renting an airplane from someone from your friend, and you're paying him for the airplane. If money is involved, it will be considered for hire. If you're going to fly an airplane over its power of gliding distance. Power of gliding distance is not a set value, it changes with the altitude. So if I'm flying at 7,000 feet over the water, which is going to be 7,000 feet vertical distance, MSL, based on the POH that I have in mind, you should always check it with your own airplane's POH. It's around 7 to 6 miles. I can glide 7 to 6 miles. If I'm going beyond that, and I'm taking passengers for hire, or I'm renting the school from the air from I'm renting the airplane from the school, I need to have uh, for each occupant, I need to have signaling devices with the life jacket. Says that you should have those on board for each occupant. You cannot go beyond gliding distance based on your cruising altitude if you don't have those two items. And the shoreline has been defined here where where the water meets the land. It's the adjacent area of water which is connects the land to the water. It can be ocean, it can be large lake, or it can be a sea. It's been defined here by the FAA. Go ahead, take a picture of this. Again, please pay attention to this. You might want to go to Catalina in California here. Since you're taking the airplane from the school, it's for hire, taking passengers yourself. It doesn't matter. If you're going beyond its power of gliding distance, you need to have life-saving jackets plus signaling devices for each occupant and be readily accessible to them. So you cannot put it in the far aft section of the airplane and they have no access to it. So yeah, it has to be under their seats or within their reach. With that being said, please pay attention to that. So let's always focus on the important things.
So just a quick one. In
Sure.
terms of that equipment, is that rentable from the flying clubs, from the FBOs, from the flying academy?
I suppose your question was about renting the airplane.
No, can we rent the? Well, is the life jackets and the flares available from Flying Academy?
Oh yes, yes, yes.
Yeah.
We have those. We have those.
Okay.
Yes, yeah. Uh, okay. So let's go ahead and do this quickly. Then hopefully we'll go ahead to other procedures as well. Plan for the weather, plan for the flight, communication, and altitude. So any of these factors during the flight planning will affect everything. Plan for the weather. We already discussed that in deep details. Know what to expect when you're taking off. Know what the weather conditions are right now, how it's going to be at your time of arrival. If you're going somewhere that you need to get back to the home base, if you see, okay, I'm seeing some bad weather is approaching this area, so I'm not gonna go there and get stuck there for 2 weeks, then I can come back. Plan for the weather. Be prepared for everything. Pre-plan the weather and the flight uh, conditions. File a flight plan. You don't have to always file a flight plan. I will explain to you how and why. You don't have to file a flight plan in US for VFR flights. You don't have to do it, but we always advise you to go ahead and file a flight plan. It's easy and quick process. You don't even have to call someone if you're using one of those apps. You just have to click on the numbers and you file it. The reason is, uh, let's say I'm going to another state, it's far away from here. If for some reason something happens to me, I lose my radios, I have an emergency, I'm landing somewhere. So if I don't get to my destination within 1 hour after that, they will try to reach out to me. If I don't pick up the phone, if they don't hear back from me on the radio, on the frequencies, on the phone, they will send search and rescue team that will come after me to find me. So if something, God forbid, never happens to you guys, you have a backup. You know that those people from the tower and emergency vehicles are coming after you. So that's an assurance to you as a pilot. Communication, be always on the frequency. Write down the frequencies. Make sure double check if you don't understand anything. Tell them, okay, can you say that again, please? Always don't be scared to verify the frequencies and instructions. If you say something back without understanding it, it will be your kind of fault if you make any mistakes. But if you say, okay, I didn't understand that, either he's going to give you something else or he's going to clarify the instruction. If even you comply with those, something happens, it's going to be the ATC's fault. But altitude, you should always aim for the tailwind during cruise and aim for the headwind during takeoff and landing. We all know at this point why and what the reason is. Tailwind will help you to burn less fuel by gaining more speed and getting there faster. By planning that, you should always be aware of the planning as well. So if you're planning for headwind, then you change the flight altitude, you get tailwind. So obviously you're gonna reach at the destination quicker and it's gonna kind of mess up the whole flight plan and the expected time of arrival with the ATC. And we know headwind, why headwind for takeoff and landings, it will shorten the takeoff and landing distance. I think we're familiar with this. Let's go ahead proceed to the next one. Get some water real quick. All right, all right. Here we have uh leaching technique. There are many ways depending on the POH. There is no kind of set procedure for everyone. Again, you would have to go through POH. Uh, how I practiced it? No. Have I done it? Obviously, no. How I went through it? Once while I was flying over the ocean going to Catalina. If you're going to plan to do the same thing, you should know the ditching technique. Ditch means you have an emergency over open body of water and you have to land on the water. For us, in a low Cessna 172 with the fixed gear, you should kind of expect this type of procedure. If you have retractable landing gear, you have an option which is more advisable, depending on the POH, to land with the gears up and kind of belly land the plane because of the water and stuff like that. But you should always go through this checklist. The first couple stages, they're the same. First, pitch for the best airspeed. Then pick the best landing area, which is open water around you. And depending on the wind that you're getting, if you're getting crosswind, you can go and adjust that. And next thing, if you're on the frequency, just declare emergency. And if you're not on the frequency 121.5 emergency frequency, declare that you have emergency. You're gonna land here. And last but not least, the most important part, if you have time, run the checklist. If you're low, if you're taking off from an island, you lose your engine, just go based on the situation and your familiarity with the checklist and POH. For landing on the water, you have a couple options. You can either uh, kind of land with the wind, parallel to the wind, or get some crosswind, depends on the waves and swells. Uh, you guys probably taking ATP course. I kind of expect you to know about these things, but let's go ahead just cover that. If you have any uncertainty, anything, go ahead. AIM chapter 6, part 3, page 3. So just go ahead. Know more about this as well. But ditching technique, you can also land low or high. You should never land on the high side of swell. Just land on the top or lowest part because it's gonna be more stable and always coordinate your touchdown. For that, you would need to kind of adjust your sync rate. The best gliding speed, it would give you a bit kind of different sync rate based on the altitude. As you're descending, you're getting closer to water. Adjust the sync rate. If you need to pitch down, if you need to pull back to kind of reduce the sync rate, go ahead, adjust it accordingly. Hopefully you will never get to use these techniques, but depends all on yourself to how to use the checklist, how to memorize it, and how familiar you are with the airplane. Just go ahead, take a picture of that. If you would like to kind of have the reference number here, AIM 633 would be our source. So let's go ahead and move on to the next one. Regular emergency, which is, I know it sounds weird, regular emergency, but the emergency that you're going to have, uh, just flying over the land, flying over any kind of flight environment that you have. For that, you guys probably heard me saying it, A, B, C, D, and some would like to include E as well. So A means airspeed, pitch for the best glide speed. So most likely you're gonna cruise at the speed higher than gliding speed. By pitching for VG, you're kind of trading off the speed for the higher altitude. So you gain more altitude. It might be a couple hundred feet, but that might save you a couple more seconds. And B, best place to land. It can be freeway. If you have airport, any airport facility, if you can land, if the runway is like 200 feet for unmanned airplanes and RC toys, so obviously you can't land there, right? But based on the situation, if you have freeway, uh, airport, as I said, land, farm, anything that is available, you should go ahead take that first. Next thing, uh, checklist. If you have enough altitude, if you have enough height, if you have enough time to run the checklist, go ahead use the checklist. If not, memory checklist always. Uh, I discussed that with an examiner. He agreed with this. So I'm just gonna bring it up here. It depends on your personal minimum and how quick you are to run the checklist. For me, if I have less than 2,000 feet AGL, I would try to run the memory checklist first. Then, if I have time, I would go ahead and pull out the actual checklist and go through it. If I'm higher, I will reach out for the checklist first, quickly go through it, then execute the rest. So we covered A, B, C. C was the checklist. And D, you need to declare emergency, either on the frequency that you're on, ATC frequency, tower frequency, approach, or departure frequency. If you're not on any frequency, if you're over practice area, you're practicing maneuvers, you should go ahead and declare that over 121.5 general emergency frequency. And you should squad 7700 to let everyone know that you have an emergency. Tell them when you declare an emergency, tell them the nature of the emergency. Basically, just a quick example is going to be your call sign Cessna 19886, declaring an emergency due to engine failure. Uh, to 3,000 feet over Van Nuys, for example, uh, planning to land on runway 16 or freeway 5 freeway, westbound, northbound, or anything that you want to include. Amount of fuel, amount of passengers on board, and if you would like to include anything else. So, two souls on board with full fuel, and just go ahead run through the rest of the checklist. Then E, meaning the executing part, just execute whatever you decided on. Execute just the normal landing, ditching the airplane. You can land on the freeway, you can land on the runway. Then you would have to go through a checklist again, configure the airplane for that particular landing. Let's see what we have here. Okay, so we're pretty set. Let's go ahead, take a 5 minute break. We'll come back at, I believe it's gonna be 8 for you guys, but by here, anyway, it's gonna be 9:58 right now. So let's go ahead and come back at 10:05. Sounds good?
All right. Thank you.
Okay, perfect. Thanks. Uh, all right, so tone of fight for me. I hope you guys are ready too. So let's continue with the rest. And we did the normal operation for non-towered airports, doing the traffic pattern, taking off or going for landing. Advisory circular AC 90-66 Bravo, and you got AIM Chapter 4, Section 3, Page 2. Go ahead, take a picture of those, take a note down, and make sure you know the references. But I will go ahead improvise that, and I will include those information as we're going through more slides. This is the advisory circular here, so you can go ahead, read it for yourself. It will give you some tips and tricks, how to be safer pilot and doing the proper radio calls when you're on non-towered airports, how to take the safety precautions and stuff like that. Uh, AIM will give you just the instruction to be safer, same thing for the same reason. Non-towered airports, as I said, I would always include those as we're talking about uh, towered and non-towered operations. For that, as we discussed many times, according to 14 CFR 91103, each pilot, even for the short flight, even for any flight that you're going to take, even in some cases, traffic pattern, you should know how long you're going to spend in the air, any no times, any problems with the ATC, runway closure, and stuff like that. But the acronym is Northwest Craft. So you should always check those and have proof that you have already checked those before taking a flight. So you should check the NOTAMs, notices to airmen. I hope we remember that. You gotta check the weather. You gotta go through the whole weather briefing and stuff like that. Known ATC delays. I already explained why. For the sake of fuel, timing, and everything that matter. Runway length. Uh, how much runway you have available to yourself as a pilot for the departure point and the landing point. What is the runway length? And alternate, you should have always pick an alternate airport in case you can't make it because of any problem. Somebody wheeled up on the runway, someone had a crash landing on the runway, so you had to deviate from the destination. Fuel requirements for your trip: how much fuel you don't burn per hour, how much fuel you don't need in total, how much fuel you don't need between each leg from checkpoint to checkpoint. Takeoff and landing distance required. Takeoff is going to be at the departure point, landing at destination. If you're going to do taxi back, come back again on the home base, you should know again your takeoff distance and landing distance. Go ahead, take a picture of this, take a note, and do a screenshot if you like. We have to go ahead and move on to the next slide. Airport diagram. This one is specific for Van Nuys. It will give you a whole bunch of instructions and information about the airport, where it's located, what kind of fuel it's available, what kind of services, maintenance services are available. If he has emergency vehicle, what runways are available. Oh, sorry, what runways are available, and what instruction you have to follow when you're doing traffic pattern, taking off, and coming in for landing, or in the remark section. If the tower is part time, it's already included here. Anything about the lights, anything, any preset no time. I really don't want to say no time, but any kind of hazards associated with the airport is already been labeled here in the remark. Frequencies, hours of operation, and approaches that are available to you as a pilot. And it includes airport diagram as well. So that's Airport Facility Directory, AFD. And this is the airport diagram for Van Nuys. We're here, so you would have to taxi all the way from this site here, and you can have an expected taxi or landing instruction: taxi to the takeoff point, and taxi from runway back to the ramp. We already discussed that yesterday, and that was just a quick review. It's available on the apps that you're going to use for flights, Garmin GPS, and also even if you go on AirNav, I will go ahead to show it to you later. AirNav, if you type the airport identifier JBNY KTMB, it will give you this plus some information about the airport as well. You should know these all of the time. And as we discussed yesterday, A was an ASOS, automated weather observation service or system, automated sensor observation system, or automated terminal information system. For the control airports, we have ATIS. For the non-control, we either have AWAS or ASOS. Mainly AWAS. ASOS is a little more advanced, but still, they do the same thing. For towered airport, as we said, for the control airports, we have ATIS. You can find the frequencies here. In this case, for this airport, which is Van Nuys, when it's the way that you get the information to generate ATIS is based on the ASOS system that they have because it's an advanced airport. So they have ASOS that you can call this number and obtain just listen to ATIS. Also, you have the ATIS number separate. So you use the ATIS to generate. They use ASOS to generate ATIS. You have the frequencies for CTAF, Common Traffic Advisory, same frequency as tower. After the hours of operation, the tower will close, and the tower frequency will change into CTAF, Common Traffic Advisory. Unicom, it's since we have CTAF, Unicom will be used for airport operations if you need fuel or anything. If you're going to land at the airport, you need fuel, and you're willing to pay that extra price for it. 10 to 15 minutes before you land, you use the second radio with the second pilot, or you advise the tower, we're going to change the frequency real quick. You call them up on 122.9 and you say, the aircraft type coming in for landing will land in 10-15 minutes. We'll need this amount of fuel, full tanks. So they're on standby. When you're landing, they will pull up and fuel up the airplane. And sorting approach frequencies, if you're departing southbound within Burbank 150 degrees, the Van Nuys 160. within that sector you have this frequency, within this sector you have this frequency, within this sector you have this, so on and so forth. Tower frequency you have two, and for the helicopters you have another one, which is here, and you have the ground frequency right here. You got the clearance delivery, as I explained yesterday. If they're merging two frequencies, so the clearance delivery will be ground as well. But some busy airports, like Van Nuys, you have clearance delivery separated and ground control and a different frequency. Rotation of the airport goes on and on, same as the last one. If I may go back here, same as last one. You get the owner of the airport, location of the airport, what kind of security uh, services are available by LAPD and stuff like that, what kind of operations to expect, noise abatement procedure, noise sensitive areas, what you have to do, what kind of fuel is available, what runway information about the runways here, and touchdown point, glide slope, what kind of services, how far is located from Van Nuys, its coordinates, and everything else like that. If you don't have any questions, we'll go ahead. I expect you to know this and go ahead, take initiative if for any airport that you're going to for the sake of time building. Go ahead, pick up AFD. If you don't have it, go ahead, let me know. I can go ahead send it to you PDF format. Find it somewhere on AirNav by yourself and review that as well. So let's go ahead. Go to the next one. We already talked about radio communication for briefly yesterday. Same thing. If you're going to a tower airport, just say who you are, who you're addressing, um, actually who you're addressing first, who you are, based on the call sign and stuff like that, where you are, and what is your intention. Just a quick example. I'm sure you're familiar with the mentioning those radio calls, but in US, this is the typical and simple way of doing it. For the sake of airport manners, or we can take Corona. Corona is uncontrolled, so without go to Miami executive. So you'll be like, sometimes they call that airport Miami, sometimes they call it Kendall. We can go any of those. Or Kendall Tower, November 19886, who you are, 10 miles to the west, 3,500 feet or 2,000, any altitude that you're at, inbound to land with information, with ATS information that you already checked, with information Bravo. So that's the typical way of doing it, where you are, what you want. That's as simple as you can get. If it's uncontrolled, you would have to first check the ABOS, ASOS, any service that is available. Either tune into CTAF or Unicom. Most likely it's going to be CTAF, Common Traffic Advisory Frequency. And it's advisable for those non-towered airports to do it 20 miles to 25 miles out. So it's going to be the same thing. I already gave you an example yesterday. Corona traffic, November 19886, 20 miles to the west, 3,500 feet, inbound to land, landing full stop, Corona. So you're gonna keep it at that short and brief. As you're getting closer, you're gonna kind of expand the intention as well. So you're gonna say Corona traffic 19886, 5 miles southwest, joining left downwind for runway 25, landing full stop, Corona. So that's the typical way of doing it. You're announcing the intention, then you will go ahead and execute it. And before you turn any late in the traffic pattern, you would have to announce it first, scan, then execute. Always announce, scan, then execute. It will go on and on, so forth for every single late, on even after the touchdown. Corona traffic system 19886 cleared up runway 25, taxi right for takeoff or taxi to ramp. Just imagine you're the ATC and the pilot at the same time. Just let the other pilots know about the intentions. Do we have any questions here? Anything? Obviously, it needs more practice. It will need you guys to be in US, so you can kind of practice it. But live ATC will be a great source for you to go ahead and practice that and get used to that. Uh, any questions here? Anything I can address? If not, before I take a picture, by all means, go ahead. We'll go ahead and move on to the next one. For CTAF, we already covered that. It can be either CTAF or Trauma Traffic Advisory or Unitram. For Corona, it's going to be same concept here. CTAF, C is labeled as C122.8, and it's already included in airport facility directory among those informations. So CTAF and Unitram are the same in this case, and most of uncontrolled airports are the same. And if they have airport operations on site and available during hours of operation, even the airport operations personnel staff, they're listening to those calls as well. So you can also take that advantage of this merge frequencies and request any type of services that are available within that facility. We already covered that. I already gave you two examples. I think we should be all right, and we can go ahead move on to the next one. And explains it here. Some airports are controlled, they're blue. Keep in mind, not every ATC facility is 24/7. Some of them are part time. You probably heard me saying it. For Venice, they're part time. The airport will go, the airport staff in the tower, the controllers will go home at 10 p.m., I believe, and start part time. But an airport like LAH, they're 24/7. There is always someone there. If the airport control tower is part time, there's a quick way to know that. On the chart, it will give you the control tower frequency with an asterisk on the right corner. The asterisk indicates that the control tower is part time. There's another way to find that and make sure it's already included in the airport facility directory. It will give you the hours of operations. It's here within 14 to 0645. And after that, it will turn into class delta. So class delta surface to whatever it is, 29999. And after that, within these hours is class delta. After that, it will turn into class echo aerospace. And this we can go ahead and move on. Any questions here? Anything? If not, we'll go ahead and continue. It's been labeled there. Yeah, there you go. And as I said yesterday, in untowered airports, there are a lot of people doing a lot of stuff without even practicing. You get some student pilots or some beginners with virtually zero ability to make radio calls. Instead of taking advantage to practice, they don't announce anything at all. You just pop up out of blue. You're on a short funnel. You're going to land. You see someone taxiing slowly on the runway to take off. Be mindful of that. Always scan. At least you do your part. Announce the intentions. Scan, then execute. If something happens, it would be kind of primarily both pilots' fault. Hopefully, never. But you should always see and avoid in VFR conditions. Even some people they say something wouldn't turn right crosswind and you see the airplane he's turning left. Some people just their brain is pretty occupied, they're busy, they forget some stuff, they make mistakes like me and yourselves. And just always see and avoid. And just the general idea about the traffic pattern, I'll go ahead and explain it and the traffic pattern later. That's more feasible. Here for landing checklist, general concept is the same. This is just a sample. You should know it for that particular airplane that you're going to take. And let's see. Okay, well, it's like this. Okay. It's already included in the website. You can go and see it for yourself for that particular airplane that you're going to fly. Basically, you make sure the seatbelts and shoulder harnesses are fastened. Briefing is complete. If you're flying with two pilots, you don't have that agreement. If the approach is not stable, if we get any, if you're flying those advanced airplanes, sync rate alert, uh yeah alarm or landing gear issues or anything doesn't look good, we don't go around come back for the second round. If you see anything abnormal, we'll discontinue, we'll go around, we'll come back for the second shot. Altimeter, you have current altimeter setting, Fuel shutter valve is at that point it should be on. Flaps as required. Make sure full reach in case of going around, and keep in mind as you're descending, air density increases, so you need more fuel. And carburetor heat on. You're at idle. The engine is cooling off rapidly, so you need to maintain some heat. And landing light on. Engine instruments check. Everything is looking normal within the green range. And before the landing checklist complete. Always have the habit of running the checklist before doing anything. It will save you a lot. It will help you a lot, and it will kind of save you from some bad incidents. Any questions here? Anything? If not, we'll go ahead and continue. And okay, let's see here. The traffic pattern, the direction of traffic pattern, right or left, standard or non-standard is already included. Right pattern for runway 30. Again, if it has tower, the tower will most likely assign you the same thing, but always follow the instruction of tower. If it doesn't have control tower, it would be your responsibility as a pilot in command of the airplane to make the call. Also, you're complying with the whatever instruction was given to you in airport facility directory here. So it would tell you right traffic pattern, runway 30, without runway 12, runway 30, runway 30, right pattern. And you know the glide approach, or you need the glide angle. It has PAPI, and you have runway and identification lights. So you've been given these information. Again, make sure you're safe. You can safety execute that. If you cannot go around, abort it, come back for the second one, and you're also complying with this. Let's go ahead, move on to the next one. And it comes to the visual indicators for the approach and landing here. In case of communication failure or just the normal operations, the towel, you already have the AWAS, ASUS, ATIS. You can check the wind if for any reason you just want to get an accurate one. Tower airports, you can ask for wind check that will give you the exact direction of at that particular moment, exact direction of wind and speed. You can go ahead have that. If you don't have any control tower, you can fly over the airport and observe the segmented circle. Segmented circle, I believe you guys are familiar with this as well. It shows you the direction of the wind and direction of traffic pattern for each runway. And those little T or L things will indicate base and final leg. Turns to the left, it turns to the left as well. So in this case, I don't have any numbers here. You see the wind is blowing from north east. You have these runways are situated in this manner. In this case, if you don't have any control tower, you would have to land here. You don't fly over the airport, observe this, and make the decision as a pilot. How can I land in this case? Wind is blowing from this side, and I have this runway. So we don't call this runway probably runway 4. So it's a left turn. This is the base lane. This is the final lane. This is the left turn. So I will go ahead, join the left traffic pattern or left downwind for runway 4 because I'm getting headwind. If it was the opposite direction, I would have gone ahead, use runway 220, right? Or runway 22 and start doing my landing. So just observe this based on the direction of the wind, make the call, and execute the landing. Are you guys familiar with this? Any questions here so far or till here for this matter? Anything?
Nope.
Okay, awesome. Great. So let's go ahead and move on to the next one, traffic pattern legs. I will go ahead and spend a little more time here. So traffic patterns are either standard to the left or right hand traffic pattern non-standard. If you have two parallel runways, you can have one to the right, one to the left. Some airports, based on the kind of availability or how busy they are, based on the controller, or even if they have some houses here, they don't want the airplanes to fly here. They will have only one runway, non-standard traffic pattern to the right. So based on the decision of the ATC and location of the airport, situation, and everything like that, they will come up with traffic pattern turns. But the typical traffic pattern lanes are the departure lane or upwind. Then you get the crosswind, you get the downwind, and base final. If you're coming to land in this non-towered airport or even towered airport, towered airport, they will tell you exactly what to do. Either they will tell you join left downwind for runway 36, or they will tell you join left traffic for runway 36. So if you're here, you will most likely gonna join left base. If you're straight coming in, so you're just gonna join the final and go for landing. If you're somewhere here, you will go ahead join the left downwind for runway 36. In case of non-towered airports, you would have to always again follow AIM 633 and 9966 Bravo. The standard procedure or the expected procedure both for non-towered airports are you would have to come in here, join the left downwind. Either if you're at the same altitude, you can go ahead and make a teardrop, join in the left downwind or the downwind for that runway. Or if you're higher, you're above the traffic pattern altitude, you have to come here outside of the traffic pattern, descend down. Once you're at the traffic pattern altitude, you would have to then go ahead and do 45 degrees innery to downwind. So first descend to traffic pattern altitude, then join the downwind. If you're at the same altitude, just make a teardrop, make a right turn, and join the left downwind. Scan for the traffic. Those radio tones are really helpful to others. It will save your life. Just have that communication. If someone else is reporting something, visualize it. If you have visual contact with the airplane, keep that visual contact. And if you see them making left turn, but they're saying right turns, be mindful of that as well. For the departure, you have a couple options. You can either do a straight at departure, or you can do, in this case it's going to be left downwind departure. In this case it's straight at departure, the same, right downwind departure. Basically, if you're going to depart, in this case from my point of view, you don't depart westbound, you're going to ask for left downwind departure. So you're going to taxi, take off, uh perform upwind, crosswind, downwind. Then halfway through the downwind you will depart at 45-degree angle. You leave the traffic pattern going toward the intended point. If you're going straight at departure, super simple. Take off, you leave the area either straight or depending on the terrain, houses, or a specific procedure again. Uh, depicted in AFD, Airport Facility Directory. For that airport, you either have to again deviate 45 degrees, leave, or going straight at toward the intended point. Same thing, but opposite for here. You can either do a straight at departure, modify the straight at departure at 45 degrees, or right downwind departure. Same thing. So then execute upwind, crosswind, and you go out at 45 degrees here. Any questions here? Anything? If not, we'll go ahead and continue. Um, just a quick thing that I should mention here. Again, depends on the procedure on AFD, but general procedure for here, you should not turn crosswind unless you have 500 feet AGL, and the point that you can turn the final, your 500 feet AGL. So basically 500 feet AGL here, 500 feet AGL here. That's the standard procedure, but depends on the airport. On Tower Airport, I already explained that. At the Tower Airport, that will tell you what to do. You know the traffic pattern lanes. Non-Tower Airport, I already said it. You can do a teardrop, join, and or you can come here, descend. Then once you're at traffic pattern altitude, you can go ahead and join downwards. Sometimes, again, it's been said on AFD, you would have to come here and straight at traffic pattern altitude, join the downwind. But normal procedure, we always, especially in Corona, we always go for this right here. Coming out for runway 25. So you have runway 25, kind of similar situation as here. You descend at traffic pattern altitude, then you join at 45 degrees downwind, you go for landing. Uh, Take a picture of this if you like, be familiar with it, and we'll go ahead, continue with the next one. Secret pattern flight is called traffic pattern. As I already explained it, you have many different options to depart. We know the lates, upwind or departure late, crosswind, downwind, base, final. You can either depart straight out or modify the straight out at 45 degrees or downwind departure, either 45 degrees out, 45 degrees out. So we're pretty familiar with this. If you guys are going to fly out of Venice, especially Florida, since you have two parallel runways, make sure because you have wind, you get some sort of crosswind. If you're departing here, make sure you're not being drifted by the wind, then find yourself flying over the parallel runway. Just be mindful of that. Is kind of more significant here, Vanish, because we get some crosswind and the runways are close together. Go ahead. Continue with the next one. You asked me this question yesterday, I believe, about the night. Night typically is the end of twilight, civil twilight, and beginning of morning, civil twilight. So that kind of section of the day, part of the day, is called night. And between sunset to sunrise, you should have your anti-collision light and position lights always on. If they ask you what is has the night is defined by the FAA, end of evening civil twilight, beginning of morning civil twilight. There is a treat that, well, not the treat, it's a regulation that would have to go and cover that. That is called night. This is typically called night. And within sunrise to sunset, which is the different sunrise to sunset, you should have your position light, anti-collision lights on, right? Just have that definition in mind. We don't come here. Based on the regulations, if you're going to carry passengers within night, right? So within end of civil twilight, beginning of civil twilight, which is called night. If you're going to carry passengers within that time, you have to be current at night. So you need to do 3 takeoff and landings at night. But to do that, those like requirements as a pilot, you need to perform that 1 hour after sunrise. I'm sorry, 1 hour after sunset, 1 hour before sunrise. So it has to be completely 100% night. I'll repeat it one more time. Night, end of evening civil twilight, beginning of morning civil twilight. That's is been defined as night. To carry passengers at night, based on the previous definition, twilight to twilight, you need to perform 3 takeoff and landings 1 hour after sunset, 1 hour before sunrise to make sure it's completely dark. Do we need more clarification here? Just go ahead, take a picture of this. Um, this might be one of the questions that examiner that's going to uh, validate your PPR might ask you. Do we have any questions here? Okay, so I'm assuming not. Take a picture of this. So to carry passengers, 3 takeoff and landings, 1 hour after sunset, 1 hour after sunrise, or before sunrise. So I need to make sure it's completely dark. 3 takeoff and landings before carrying passengers. So if you're going to carry passengers, 3 takeoff and landings by yourself, then you can carry passengers at night within the definition that I gave you. If anything, though, let me know. If not, I will assume that you already had the definition down and you have no questions. To carry passengers at night, you need to be current. and we know how at this point. Set, set your picture. We'll go and move on to the next one. To fly at night, uh, you need to be PIC, and it explains it here. Same exact thing that I said. Within 90 days to carry passengers through takeoff and landings to the full stop prior to carrying passengers 1 hour after sunset, 1 hour before sunrise, and is are the regulation codes and sunset to sunrise, anti-collision light and position lights on. Same thing. These are the reference numbers to that far aim. Let's go ahead and move on to the next one. Minimum equipment list. If you remember, I already explained it. Since the airplane weighs less than 6,000 pounds, we don't have typical equipment list, but FAA came up with this list that we call it minimum equipment list for us for light airplanes. Minimum equipment list for day, and we have minimum equipment list for night. For day is this, for night this plus this. There's an acronym that you can use. I believe it's included here. No, okay. A tomato flames. A tomato flames. And you got for night, you got flaps. So basically for night, it's going to be A tomato flames plus flaps. What are those? You need airspeed indicator, atometer, the RPM gauge, and you have oil pressure gauge, manifold pressure gauge wouldn't apply to us unless you're flying our templates or high performance. Altimeter, temperature gauge for each liquid cooled engine. We don't have liquid cooled engine. We have air cooled engines, so that wouldn't apply to us. Oil temperature gauge, so the oil pressure and oil temperature both. Flotation devices plus flares. If you remember, I was talking about carrying passengers for hire over the water. Uh, life jackets plus signaling devices. So that's that. Fuel gauge does not have to be accurate unless the fuel tanks are empty. Fuel gauges must show zero on everything other than that. It would be your responsibility as a pilot to check it, but fuel gauges doesn't none of the fuel gauges have to be accurate unless the fuel tanks are empty. It should show zero, but you need to have fuel quantity gauges to be legal. Landing gear position light. If you're going to fly a complex airplane, landing gear position light, anti-collision light, magnetic compass, ELT, seatbelts, and shoulder harnesses if installed. We go for night. Got 8 tomato flames plus flaps. So you need to have everything from day plus these. Fuses. I don't believe we have any airplane running on fuses for us. But if you're flying an airplane that uses fuses instead of circuit breakers, you need to have 3 sets for each individual fuse. Landing light, anti-collision light, position light, and source of power. Your alternator or generator has to be working. I'm gonna let it sit on the slide a little bit. Go ahead, take a picture, please. Let me know if you would like me to repeat it. It's 91205. Please take this serious. Any questions, anything, I'm here. Take a picture. And meanwhile, I'm checking time. We can go ahead and proceed if you guys are done. Oh, it's really important. That's the same thing for A. Minimum fuel. You need to fly from point A to point B, and the point B is point of intended to land, your final destination. Plus that, you should be having enough fuel to fly 30 minutes at normal cruising speed after reaching the final destination point. So 30 minutes at normal cruising speed after that. For night, it's the same thing, 45 minutes. These are the minimums by the FAA. But always be safe. Oh, you need more fuel than this. That's just the bare minimum to stay legal. For Flying Academy, regardless day or night, is 45 minutes. Well, one more time. 91, 151. From point A, takeoff point, to point B, final destination. And after reaching the final destination, flying for 30 minutes, normal cruising speed for day, 45 minutes for night. Take a picture, take some notes down, or do I move on to the next one? Visibility, we already covered that, I believe, yesterday. Uh, I, if you like, we can go ahead cover that again. If not, we'll go ahead kind of not bypass it since we already covered it. So we're gonna just do a quick recap. Class Alpha, no weather minimums because no VFR flights are allowed. Class Bravo, 3 statute miles, clear of the clouds. Class, class Charlie, Delta, and Echo below 10,000 feet, 3152. 1,000 feet above, 500 feet below, and 2,000 feet horizontally. Class Echo, above 10,000 feet MSL, 5111. 5 statute mile visibility, 1,000 feet above, 1,000 feet below, and 1 mile horizontally. Class Golf, below 1,200 feet AGL, during day, 1 statute mile and clear of the clouds. At night, 3152. And if you're within 1,200 feet AGL, but less than 10,000, you got 152 for day and 152 for night. And you're above 10,000 feet in class golf, 5111. Same concept. If you need to take a picture again, by all means, go ahead. And we'll go ahead continue to the next one. Flight planning, you're gonna pick some points, some waypoints, some checkpoints, anything. If you're navigating by GPS, you should have visual references on the ground, also waypoints, checkpoints on the GPS, and checkpoints on the ground, landmarks, and stuff like that. It can be any building as long as it's something known, like anything that is kind of known to the public. We had a gentleman navigating to one other airport. Uh, his checkpoint was his grandfather's house, so that wouldn't really count. It will help you. It would definitely help you to measure the distance, but that wouldn't really be a great option. So just pick something intersection, any kind of known farm, any building that is kind of known to the public. It has a name. Pick that, and the checkpoints are should be between 25 miles to 40 miles. You can pick checkpoints within 60 miles too, but it's advisable to stay within 25 to 40 miles apart. You can use the VORs, you can use the GPS waypoints and flight points, and you can even use some airports as well. Don't use the mountains, don't use the fields, any like orange field or apple farm or stuff like that. So don't use those. Don't use the forest because they're similar. It might lead into confusion. During the day, double checking on the GPS, on your flight plan and landmark on the ground. During night, same thing. Check it on the ground if you can, based on the lights. Check it on the flight plan and check it on the GPS and your for flight. And pay attention to minimum elevation feeder. I would have to show it here. Minimum elevation feeder here, 4151. These are the elevation of the highest obstacle within this quadrant. Within this area here, the highest mountain is 5,200 feet MSL. Here, 4,100 feet. Here, 5,600 feet. Just pick the alti. If you're going from Van Nuys to another airport here, You can cruise at, I don't know, 3,500 feet. So it should be at least 4,500 feet or more. So you can pitch either 45, which is not really safe, or I would go with 65 and 6,500 feet. If you're going the other way, you should pay attention to minimum elevation feeder, those other part of the area. And here, the yellow areas are the populated or congested areas on sectional and terminal charts. You will see it on the strike vector for flight and stuff like that. It's been shown. It has lights, and population of city is concentrated within these areas. Let's go ahead and move on to the next one. You can also definitely use these at night to navigate as well. For lighting, this is a great picture. Let's go ahead to focus on those two images. As we discussed yesterday, taxiway edge lights are blue, taxiway center lights are green. Approach to the runway, beginning of the runway, you see those green lights. End of the runway, you see rails, runway end identification lights, red. If you're coming to land from this way, you see this opposite. This one would be green. You see it as green lights. They're they're unidirectional. They're not omnidirectional. They're just unidirectional lights, meaning there is a kind of section between two sides of two portions of the light. One side uh, alone is green, the other side is red. Same thing here. And let me take some water. I can barely keep up right now. All right. And here, runway center lights are white, edge lights are sequential, last 2,000 feet, or half of the runway, whichever is less, turns into red and white, and it goes gradually yellow, red and white, sequential, and last 200 feet will be red. Runway center lights, same thing as already explained. And if you're going to lead off of the runway, you get yellow and green lights in sequence. Go ahead, take a picture of this. If you'd like me to explain it one more time, I will be more than happy to. Any questions here, I would take it happily. If not, we'll go ahead and move on to the next slide. Mm, The touchdown zone is 900 meter, uh, typically 1,000 feet, but I don't know what they put in 900 meter. From here to here is 1,000 feet. And runway edge lights, you see the whole thing. Basically, the red lights, you get the PAPI, you're on the glide slope. Based on what I see, is two whites, two reds, and everything's being shown there. Rails, runway end identification lights, red. Beginning of the runway, green. And you got those taxiway lights. Edge is blue. Center is the green. And if I'm not kind of spend a couple seconds on it, that would be great. So if you guys are okay with it, we don't go to the next one, and the lights of the airport. Based on the beacon light that is located in the airport, you can tell what kind of airport it is. Civil airport, military airport, heliport, and water port or water airport, which sounds weird. So one green, one white is a civilian land airport. It's on the land, open to the public. If you see one white, one yellow, it's a water airport. It's an kind of airport on the water. And if you see yellow, white, and green, it's a heliport. And two white, one green, military airport. So your concern should be mainly this and this. If you're going to land an airport, you see this, that's a military airport. You might not be able to see it to land unless you have an absolute emergency. If you see this, most of the like we're used to see this, one white, one green, it would be just normal public civilian airport. If we're going to fly over the water, you see the water airport and the heliport. It doesn't matter over the water or over the land, it would be the same thing. But anything other than that should raise a concern for you because it might be something like military airports or heliports or stuff like that, so you can't go there. This beacon light is open. Oh, I'm saying it's open. It's on during IFR condition, day and night, and within sunset to sunrise, it's always on. I believe we're finished with the slides. I would like to take a 10-minute break. We'll come back. Well, so let's make it 8 minutes. We'll come back at 11 for me. I believe it's gonna be 8 for you guys. I would like to spend a couple minutes, just 10, 15 minutes or less, to check the weather one more time, to show you the weather sources, go over the charts, and we should be done. Sounds good?
Sounds good for me.
Awesome, great.
Where are you from, Amir?
I'm from Iran.
You was born in Iran or in?
Yeah, yeah, I was born in Iran, yes.
Okay, so when did you go to America?
It's been 6 years now, 5 years.
5 years. Okay. How old are you?
23.
23. Okay,
It's about to turn 24 in 4 months.
nice.
Yeah.
And you already finished your CPL?
Yes.
Uh, and do you want to make the ATP or?
We need to have 1,500 hours for US for ATP. Yes. Hopefully, yes. By that time, I get my hours. Yes.
You can't have a frozen ATPL.
Uh, in US, we can't.
Okay.
Yeah,
Well,
unfortunately. Yeah.
that's expensive.
Yeah. The courses are cost wise. Yes, it might be, but even if I get the frozen ATP from EASA, it wouldn't count in US. So it has no value, unfortunately, in US.
Mm.
That's the
I
sad
don't
portion.
know if it's easier to get an EASA license than an FAA.
Probably, I would say equal amount of effort, but being easier, I believe kind of FA ones are kind of easier.
The theoretical part of the other is really bullshit. It's unbelievable.
I see. Yeah,
It's 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 terrifying.
especially for that ATP. So you would have to know the exact components. Yeah,
Not only this, the questions, the data questions
it's a
it's
lot of stuff.
unbelievable. It's like English of a third grader, of a maybe 4-year-old child. You read the question, you're just like, what the fuck?
I see. But at the end, even for us, we have to do it anyway. So
Yeah,
kind of would benefit you guys, though. To be honest with you.
I finished 12 exams. Now I have to finish performance and planning. These are
Wow.
my last exams. Then I finish the theoretical ATPL.
So it has 14 tests,
Yes,
14 exams. Wow. Wow.
and last week I finished my last simulator sessions for the IR rating,
Oh, nice. Awesome.
and now I think we have to fly 50 or 55 hours in California. Then when
Yeah,
we
around
come
the
back,
50 hours.
uh,
Yeah.
then we fly our IFR hours, CPL hours, and then MEP for multi-engine.
Oh,
Then we are finished.
perfect. 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 Nice. So you can also practice some ILS approaches here, but you would need to have a safety pilot.
I think in every flight we need a safety pilot.
Or even simulated instrument training, you will need to have a safety pilot with you.
Yeah,
At
but
least in the US. At least in US.
yeah, I know. But on all our flights, I think we're not allowed to fly alone. Or
Oh,
it's
okay. All right then.
requirement from the school. I'm not sure.
Oh, I'm not sure. Yeah, if you're kind of restricted to have someone with you, so that's also
But I'm glad
possible.
that I don't have to fly alone because
Oh,
the
it's fun.
airspaces look really terrifying.
It's scary. No, no. Once you get to know the aerospace, you get a little comfortable. Five,
We
10
don't
hours
have
here is around
we
five,
don't
10
have
hours.
airspace Alpha and Bravo here in Austria. Only Charlie, Delta, and Golf.
To be honest, same thing. It's very close. Very, very close. Bravo, you most likely not gonna go through any Bravos, depending on the destination. Anything else, I believe it's the same concept. So just gonna take some fun cross countries here. I know it looks scary, I know that.
Is it
But
possible to fly from Corona to Las Vegas?
yeah, that's a great trip. As a
How,
matter of
how,
fact, let
how
me go
long
ahead.
does it take?
From Corona to over there, it's gonna be around 1 hour 40 minutes, one leg.
Wow, one leg. And is it possible do we need to get back on the same day, or maybe we can stay overnight? For example, anything in Las
I
Vegas?
believe, don't pin me down on it, but I believe if we don't have any other flights to schedule for that airplane, you may stay overnight, but I don't believe you're authorized to fly at night. So either you have to get
Yeah.
checked out,
Okay. Well,
yeah, that kind of stuff. Yeah.
I don't want to fly at night. I don't want to fly VFR at night, especially on a place that I don't know.
That's actually good. So you're thinking about being safe. So that's really good. Yeah, the unknown places, especially at night. Here, Vegas is a little, high terrain and stuff like that. It's a little kind of
Is it possible
sketch.
to make a fuel stop and then to fly to the Grand Canyon, for example?
Depending on flight plan, like possibility, yes, of course it is.
That
But
would be awesome.
depends how you would like to perform it, though. Like depends on your kind of flight plan and stuff like that.
Okay.
So as we don't draw it at the same time, drawing through some charts as well, as I said. So that would be a
Mhm.
great starting point for us. I'm in a strike vector here, trying to go down to California and Southern California, LA area without a TFR. Disneyland, Corona Airport is right there. I can see it. So you guys see my screen?
Yes.
Awesome. So this is the Corona Airport. Uh, it had the aerospace here, which is Charlie.
Mm-hmm.
As we discussed, we can stay on the frequency for the safety reasons. Some people they prefer not to, but again, my point of view, once you're taking off from Corona here,
Yeah.
you can stay over this area, climb to probably 5,500, and as you're climbing, you can go and call departure controller 135.4 or SoCal, so
Mm-hmm.
SoCal departure. As for VFR flight following to Vegas at 5,500 feet, then once you're in contact with SoCal, you can technically speaking go through any airspace except Delta, and he would have to kind of clear you for Bravo. But so far, you wouldn't encounter any Bravos here. It's just Charlie. You climb out. You start going from Corona. You can take basically freeways, 15 freeway, 215. But it's pretty straight flight. You got to this point here. There's a path that you need to go through. You got some roads, 215 freeway, I believe, railroad. You can continue that. You have options or airports on the right in case of emergency. Just follow the VORs. You got the Daggett,
Mm-hmm.
Valley, Barstow. MOA, if it's hot, you would have to deviate. Still,
Mm-hmm.
you're following 15 freeway, going all the way to
And I think
Henderson Field. Yes, I would have to
we
do.
also have to finish our 300 nautical miles flight, our CPL 3 Uh,
300 nautical miles. I believe it's 300 nautical miles, 250 in a straight line. I don't know how would it work in Europe.
need at least 17 nautical miles. You need to fly at 3 airports, from one airport to the
Yeah,
another, then to another, and then back. And I need at least 17 nautical miles distance. I'm
no,
not
it should
sure.
be all right.
I will ask also our head of training.
No, it should be all right here. For that flight, you get at least like 120 here on the straight line. So that wouldn't be a problem. So that would be kind of working out for you. Henderson Field, the main Vegas airports, you can absolutely go ahead and land there. Fees are a bit higher. You run some other issues with the controllers. It's pretty busy. A lot of people just go to this airport, North Las Vegas, just
Hmm.
land there. It's underneath the Bravo, and the you see the Bravo starts at 4,500 MSL, but the class Delta finishes at 449.99. So you can also kind of deviate a little to the left and call the tower, descend down to probably 3,000 feet. Sounds about right to me. You can go ahead and land there.
Okay, nice.
It's absolutely doable though. But always make sure you're familiar with the aerospaces.
Hmm.
I would be more than happy to hop on the airplane to be your safety pilot, but always make sure about those aerospaces, legality, and stuff like that. Speaking of which, do you have any questions left here for the aerospaces?
Uh, at this moment, not. I think we can continue with our lesson. And
Sure. The actual slides are done for today. I would just like to take a couple more minutes from your time to go ahead
okay,
cover some weather. We're gonna go to weather here. A- AWC, the website that you see here. Uh, When you type it out, it will open up this page. You would have to go it depending on the what you're trying to get. I'm sure at this point we're comfortable with METARs and TAF, pilot reports and airmets, segments and convective segments. So we're kind of comfortable with these, right? We can go to advisories. Same thing. We can probably check one convective segment, see where it's at.
so you
And
can watch the segments of the whole world.
yes, that is great. That is great. Surprisingly, no convective segments here. Okay, so okay, it's only over the US. Yeah. All right, so let's see what we got here. A whole bunch of stuff going on. Oh, actually, let me see. I can slightly zoom in. Using the laptop. It's a little bit difficult. So if you click on this, will show you this. That's a convective segment. It has the validation time, the issue time,
Hmm.
m- moderate, it goes light, moderate, and severe. Tops at 41,000 feet MSL, and base starts at
But
18,000 feet.
but I will never fly 18,000 feet with a Cessna.
Yeah, exactly. But keep in mind, though, keep in mind, you made a great point. But if you have convective segment, it's convective, going up and down. You might get some thunderstorm. So even if you're flying at 10,000 feet, you might still get some heavy downdrafts, though. So it's a thunderstorm. You can never fly underneath it, right?
I don't know.
Yeah. So you made a great point. Some of them they wouldn't apply to you because you're not going to go that high. If you get freezing level, it wouldn't be really applicable here. Freezing level, if you're getting freezing level at I don't know 15,000 feet, if you're going to fly at 7,000 feet, it's not going to be really an issue depending on the day and weather. But there might be also some different freezing levels as well. One area might be freezing level, on top of it, not freezing, but still don't be cold. On top of it, again, freezing level. So there might be multiple levels. Forecast, you can get the convention. Keep in mind, area forecast, uh, it was discontinued, I believe, 3 years ago, and they changed it to GFA. So you would have to collect it area forecast when you're going to fly to another airport, which is middle of nowhere. You
Hmm.
don't have any tab for it. Uh, the one way you can get kind of expected information about that specific time, you could check the area forecast. That will give you a forecast for a wide area, for a large area. Since it's been discontinued, they changed it to GFAs. For GFAs, you just collect on it based on the stations that they have available, probably around this area, as I was pointing out. If you click on it, it will give you this. So kind of similar to area forecast, but they changed it to GFA. It will give you rough estimation about the forecast within that time. The other thing, if you don't have any questions, the radar. Again, be careful with the radars. They might show clear, but it does not guarantee 100%
Yeah, I
be
know.
a bar. Yeah, so just be careful with that. I've seen some people getting kind of confused and have the price charts. We can go through those. I can probably do it. This is for the mid level. We already covered a similar thing. Two panel for first 12 hours, second 12 hours, 12, 24 basically. And you did the surface is on mainly the observation. They're not forecasts, mainly observation for that particular time. And if you click probably, I would say here is fine. So we'll give you all information here. You can go through it, but mainly for our concern it's just going to be surface plot charts and low level plot charts. I believe. Any questions so far? Anything?
Um, Not on this chart. Um, so
Regarding
the weather in California is the most time good, I think, for flying.
Yes, all the time, dude. Like
Okay.
couple days here and there, you might get some kind of rain and stuff like that, but the rest you're good. If you're going a bit earlier this year, around early November, couple days again, early morning we had some low visibility, but right now it just it's either rain or good. So right now we have some clouds, but they're high ceilinged. I believe
Yeah,
the
we, we, of-
21,000 feet.
we often have low visibility here in Salzburg.
Oh,
And
and
we,
it's super cold.
yes.
So
Well,
that's the main
uh,
issue. Yeah.
for flying, it's better to be cold than warm, believe me.
But you don't run into a lot of issues though with the cold weather.
Yeah, the most problematic thing is the startup of the engine. If it's too cold, you need to warm up the engine.
That's true. Yeah, yeah.
That's the biggest drama, but all the other
No,
things are much more relaxed.
I'm sure. Yeah, here just if you're going to do some summer flying here, I don't think it will be matching your time frame. But
But
summer it gets
we are
pretty
flying
crazy.
from the 2nd January till 20, I think,
That
18 days.
you're coming for the best weather,
Oh,
like perfect weather.
that's
That time you get perfect weather. Yeah.
that's nice to hear. Do
Um,
you have any other issues? For example, strong winds in California?
strong winds within that time frame. No, a little bit after that, you might get some heavy crosswinds, some dust. Couple days though. It's not like constant for 2 weeks. Couple days, and beginning of the winter, probably August ish. Again, dust and crosswind because of the situation of the airport, the pass that we have here. Otherwise, it's calm.
Okay.
The main issue here is the high elevation and high temperature here in California. So those are the main two issues.
Okay. So we have very strong winds in Austria because of the Alps.
Oh, right.
It's
I
do
see.
you, I think you will know on the Rocky Mountains the Chinook, the strong winds.
I see. I see. Yeah,
Uh,
yeah.
I think you will know the Chinook, the strong winds in the Rocky Mountains.
I just heard it. Yeah, those winds are blowing at
Uh,
110 miles. Yeah, those are just crazy. Just give me 1 second so I can go ahead and stop the recording. Just 1 second. I will go ahead and stop the recording right now so we can keep the rest. Thanks so much. We'll see.